Imagine a star, but not the kind you know. Not a ball of burning hydrogen or a collapsing neutron core. Imagine something far stranger, something that defies the very laws of physics as we understand them. What if entire stars were made of exotic matter? Matter that doesn't behave like anything we see on Earth, matter that bends reality itself in ways we can't even fully grasp. Could these stars be lurking in the depths of space, hidden among the countless others? And if they exist, what would that mean for the universe? Exotic matter isn't just some random science fiction idea. It's a real concept that physicists take seriously. In fact, some versions of it are essential to theories about wormholes, dark energy, and even time travel. But here's the crazy part. We don't even know if exotic matter actually exists in large amounts. It might be out there, forming strange stars in some distant corner of the cosmos, or it might not exist at all. But if it does, it could change everything. To understand this, let's start with the basics. What is exotic matter? The term itself is a bit of a catch-all. It refers to any form of matter that doesn't follow the usual rules of physics. On Earth, everything we see, rocks, water, air, people, is made of atoms. Atoms have protons, neutrons, and electrons, and they obey predictable laws. But in the universe, there could be other kinds of matter that don't follow those rules. Some of these have been proposed in physics theories, but have never been observed directly. One of the most talked about forms of exotic matter is negative mass. That's right, mass that's actually negative. If you push something with negative mass, instead of moving away, it moves toward you. Sounds impossible, right? But mathematically it works. And if stars made of this kind of matter existed, they wouldn't behave like normal stars at all. Their gravity would be completely different. They might even repel normal matter instead of attracting it. This kind of exotic matter is one of the ideas behind stable wormholes, bridges through space-time that could let you travel faster than light. But negative mass isn't the only possibility. There's also strange matter, a hypothetical type of matter made up of strange quarks. You've heard of protons and neutrons, right? Well, they're made of smaller particles called quarks. Normal matter contains up and down quarks. But if you add a third kind, strange quarks, you get something completely different. Physicists think that under extreme pressure, like in the core of a neutron star, matter could transform into strange matter. And here's where things get really weird. Strange matter is thought to be stable. If it comes into contact with normal matter, it could convert it into more strange matter. That means a single tiny piece of it could start a chain reaction, turning an entire star, or even an entire planet, into strange matter. Some scientists have even suggested that neutron stars could collapse into strange stars, where the entire thing is made of this bizarre substance. And then there's dark matter. We know it's out there because of how galaxies move. There's extra gravity that we can't explain with the matter we can see. But we have no idea what dark matter actually is. Some theories suggest that dark matter might form its own kinds of structures, including stars. These wouldn't be like normal stars at all. They wouldn't shine in the way we're used to, because dark matter doesn't interact with light the same way regular matter does. But they could still have mass, still generate gravity, and still shape the universe in ways we don't yet understand. If dark matter stars exist, they could be hidden all around us, completely invisible but still influencing the galaxies they sit inside. So what would a star made entirely of exotic matter actually look like? Well, that depends on the kind of exotic matter it's made of. If it were a strange star, it might be incredibly dense, possibly even denser than a neutron star. It could be surrounded by a thin crust of regular matter, but inside, it would be something completely different. If it were a dark matter star, it might be nearly invisible, only detectable by the gravitational effects it has on surrounding space. And if it were made of negative mass, well, we have no idea. It could be something so bizarre that it doesn't even resemble a normal star at all. One of the biggest questions is whether we could ever find one of these stars. The problem is, if exotic matter exists, it might not interact with light in the same way normal matter does. That means traditional telescopes wouldn't be able to see them. But there are other ways to detect objects in space. One of them is through gravitational lensing. This happens when a massive object bends the light coming from something behind it. If an exotic star were out there, we might be able to detect its presence by the way it bends the light of background stars. Another way would be by looking for unusual gravitational waves, ripples in spacetime that happen when massive objects move. If exotic matter behaves differently from regular matter, it could create gravitational waves with signatures that don't match anything we've seen before. There's also the question of how these stars would form. Normal stars form when clouds of gas collapse under gravity. But if exotic matter exists, does it follow the same process? Could there be entire regions of the universe where exotic stars are more common than normal ones? Some theories suggest that exotic matter might have been more common in the early universe. If that's true, then exotic stars could be relics from the birth of the cosmos, ancient objects that have been around since the beginning of time. And what if exotic stars aren't just out there in some distant galaxy? What if they're closer than we think? Could there be exotic stars lurking inside our own Milky Way, hidden among the billions of regular stars? Could they be influencing the structure of our galaxy in ways we don't even realize? It's possible. And if we ever find one, it could change our entire understanding of the universe. But here's where things get even crazier. Some scientists have speculated that if exotic matter exists, it could be used for advanced technology. If we could harness the properties of negative mass, we might be able to build warp drives or create stable wormholes. If we could tap into strange matter, we might unlock entirely new forms of energy. And if dark matter stars exist, they might hold the key to understanding one of the biggest mysteries in physics: what dark matter actually is. So, could entire stars be made of exotic matter? The answer is, maybe. We don't have proof yet, but the possibilities are too fascinating to ignore. The universe is far stranger than we ever imagined, and we've barely scratched the surface of what's out there. What if the most bizarre stars in the universe are the ones we haven't even discovered yet? The idea of exotic stars isn't just a wild fantasy. It's something that could rewrite the fundamental laws of astrophysics. If these stars exist, they would challenge everything we thought we knew about how celestial bodies form, evolve, and interact with their surroundings. But one of the most intriguing questions is, if exotic stars are out there, could they play a role in the ultimate fate of the universe? To understand that, we need to talk about what happens to stars over time. Normal stars, like our Sun, go through a life cycle. They burn hydrogen, then helium, and eventually reach the end of their lives as white dwarfs, neutron stars, or black holes. But what about exotic stars? Do they age? Do they collapse? Or do they remain stable forever? If a strange star, for example, is made of self-sustaining strange matter, could it theoretically exist indefinitely? And if negative mass stars repel normal matter instead of attracting it, could they avoid collapsing into black holes? And then there's the question of what happens if exotic matter interacts with regular matter on a large scale. Could an exotic star have a catastrophic effect on its surroundings? Some theories suggest that if a neutron star ever came into contact with a large enough quantity of strange matter, it could trigger a complete conversion into strange matter, wiping out any normal atomic structure within it. If this process isn't limited to stars but could also affect planets, it's possible that an exotic star could be a kind of cosmic destroyer, turning everything it encounters into something unrecognizable. But let's take things even further. If exotic stars exist, how rare are they? Could they make up a small fraction of the universe, or could they be far more common than we think? We assume that most stars are made of normal matter because that's what we observe. But what if we've been looking at things the wrong way? What if exotic stars don't emit light in the way we expect, making them essentially invisible unless we specifically look for their gravitational effects? That would mean the universe could be hiding entire clusters of exotic stars, undetected and waiting to be discovered. And speaking of hidden things, what about dark energy? We know the universe is expanding at an accelerating rate, and the leading explanation for this is dark energy, a mysterious force pushing galaxies apart. But what if exotic matter is somehow linked to this? Could exotic stars be generating or interacting with dark energy in a way we don't yet understand? If so, then the presence of exotic stars could be directly influencing the expansion of the universe, making them one of the most important factors in cosmic evolution. But now, let's flip the question around. If exotic stars are possible, why haven't we found one yet? The simplest answer is that we might not have the right tools to detect them. Our current telescopes rely on observing electromagnetic radiation, visible light, X-rays, radio waves, and so on. But what if exotic stars don't emit radiation the same way? What if they shine in a spectrum of energy we've never even considered looking at? If that's the case, then they could be right in front of us, hidden in plain sight. This brings us to another fascinating idea. What if exotic stars don't just exist, but they're fundamental to the structure of the universe itself? Some theoretical physicists suggest that exotic matter might be woven into the fabric of reality in a way we haven't yet grasped. If that's true, then exotic stars could be acting as anchors, holding galaxies together or influencing the very structure of space-time. And then there's the biggest question of all. Could exotic matter be linked to life itself? We assume that life, as we know it, requires normal matter, carbon, hydrogen, oxygen, and so on. But what if an entirely different form of life could exist, one based on exotic matter? If that's the case, then exotic stars might not just be strange objects in the sky, they could be home to entirely new forms of existence. What if the reason we haven't found extraterrestrial life is because we've been looking for the wrong kind of life? What if advanced civilizations exist, but they're not made of atoms like we are? What if they exist within the framework of exotic matter, living in a way we can't even begin to comprehend? If so, then exotic stars wouldn't just be scientific curiosities. They'd be windows into an entirely different kind of universe. And here's where things get even crazier. Some scientists have proposed that exotic matter could be linked to the multiverse, the idea that our universe is just one of many. If that's true, then exotic stars might not even belong entirely to our universe. They could be remnants of other universes, leaking into ours in ways we don't yet understand. If exotic matter has different physical properties from normal matter, then it might be evidence that other universes exist with different rules of physics. That leads us to an even deeper question. What if exotic stars are actually doorways? Could they be connected to other universes? If exotic matter interacts differently with space-time, then it's possible that exotic stars might serve as natural portals, linking different regions of the cosmos or even different dimensions. At this point, the possibilities start to sound almost supernatural, but that's the nature of science at the edge of our understanding. The universe is stranger than we ever imagined, and every time we think we've figured it out, something new comes along to shatter our expectations. Exotic stars might be one of those things. They might be the missing piece of a puzzle we didn't even know we were trying to solve. The more we study the cosmos, the more we realize how little we actually know. If exotic stars are out there, waiting to be discovered, then they could unlock secrets that go beyond anything we ever imagined. They could teach us about the nature of reality, the origins of the universe, and even the future of space exploration. And maybe, just maybe, they could show us that the universe is far bigger, far stranger, and far more mysterious than we ever thought possible. If exotic stars exist, their implications would stretch far beyond just astrophysics. They could change the way we understand the very fabric of the cosmos. One of the biggest questions in modern physics is how matter and energy behave at extreme conditions, and exotic matter could be the missing link in answering some of the most puzzling mysteries about the universe. For example, let's talk about black holes. Right now, black holes are thought to form when massive stars collapse under their own gravity, creating an object so dense that not even light can escape. But what if some stars don't collapse into black holes in the traditional way? If exotic matter resists gravitational collapse or behaves in unexpected ways, it's possible that some objects we assume to be black holes might actually be something else entirely. Exotic stars that mimic black holes but have completely different properties. And if that's true, then what does it mean for things like event horizons and singularities? Could exotic stars be objects that prevent true singularities from forming? Or could they create new kinds of singularities, ones that don't obey the normal laws of physics? Some physicists have even speculated that exotic stars could form stable structures in the place where we'd expect black holes, meaning that some of the black holes we've observed might actually be something even stranger. Then there's the question of dark matter. Right now, we think dark matter makes up most of the mass in the universe, yet we don't know what it is. It doesn't emit light, it doesn't interact with normal matter in the usual way, and we can only detect it through its gravitational effects. But what if some of the dark matter in the universe isn't just diffuse clouds of invisible particles, but entire stars made of exotic matter? If these stars exist, they could be hidden all around us, forming structures that shape galaxies without us even realizing it. If that's the case, then dark matter might not be some strange, unknown particle. It might be something much bigger, entire star systems, galaxies, or even cosmic structures made of a completely different kind of matter. And if that's true, then our entire understanding of the universe would need to be rewritten. But let's go even further. If exotic stars exist, could we ever reach them? If we found one, would we be able to study it up close? Right now, our ability to explore space is limited by how far we can travel. But exotic matter might hold the key to faster-than-light travel. Some theories suggest that exotic matter could be used to stabilize wormholes, hypothetical shortcuts through space that could allow us to travel vast distances instantaneously. If exotic stars are made of the same kind of matter needed to create or sustain wormholes, then studying them could be the first step toward unlocking interstellar travel. And if that's the case, then exotic stars might not just be fascinating objects in space. They might be the key to the future of space exploration. If we can understand how exotic matter works, we might be able to harness it, manipulate it, or even use it as a new energy source. If exotic stars contain matter with negative mass, for example, then they could be the perfect fuel for futuristic propulsion systems that defy the limitations of normal physics. And if so, what does that mean for our future? If exotic stars exist, then they've been out there for billions of years, shaping the universe in ways we don't yet understand. Could they be influencing cosmic evolution? Could they be responsible for unexplained astronomical phenomena? Or could they hold the answers to questions we haven't even thought to ask yet? One of the biggest mysteries in physics is why the universe has more matter than antimatter. In theory, the Big Bang should have produced equal amounts of both, which means they should have annihilated each other, leaving behind nothing. But instead, matter won out, and we exist because of that imbalance. Could exotic stars be related to this mystery? Could they be relics from a time when the balance between matter and antimatter was different? If exotic matter behaves differently than normal matter, then it's possible that exotic stars existed in the early universe and played a role in the way matter and antimatter interacted. Maybe they were common at the beginning of time, shaping the universe in ways we don't yet understand, and only a few of them still remain, hidden in the depths of space. And that brings us to another fascinating question. Could exotic stars be artificial? What if these objects aren't naturally occurring at all? If an advanced alien civilization had access to exotic matter, they might have created entire stars out of it. These stars could serve as massive energy sources, gravitational anchors for interstellar structures, or even as experiments in manipulating the fundamental forces of nature. If that's the case, then finding an exotic star wouldn't just mean discovering a new type of celestial object. It would mean discovering evidence of a civilization far beyond anything we've ever imagined. And if that's true, then the universe might not just be full of exotic stars, it might be full of megastructures, artificial planets, and cosmic engineering projects beyond our wildest dreams. But if exotic stars exist, and they've been around for billions of years, then why haven't we seen them yet? Why haven't we found direct proof of their existence? The answer might be that we simply haven't been looking in the right way. Right now, most of our understanding of the universe comes from observing light. But what if exotic stars don't emit normal light? What if their radiation is in a spectrum we don't normally look at? If that's true, then we might have already detected them without realizing it. Some unexplained cosmic phenomena, like fast radio bursts or ultra-high-energy cosmic rays, might actually be signals from exotic stars. If we reanalyze this data with the idea of exotic matter in mind, we might find that these mysterious objects have been hiding in our observations all along. And if we do find one, what happens next? Do we send a probe? Do we try to interact with it? If we encounter an exotic star, we might be faced with entirely new physical laws, forces, and interactions that we've never seen before. We might even have to rethink the way we define matter, energy, and the very nature of existence itself. The universe is vast, mysterious, and filled with things we don't yet understand. But exotic stars might be one of the strangest discoveries waiting to be made. They could rewrite the laws of physics, reshape our understanding of space, and even change the way we think about life, intelligence, and the future of exploration. If we ever find one, it won't just be a breakthrough in astronomy. It will be a revelation about the true nature of reality. And the deeper we look into space, the more we realize one simple truth: the universe is far stranger, far bigger, and far more mysterious than we ever imagined. If exotic stars exist, then the universe might be filled with objects that defy our current understanding of physics. But let's take this one step further. What if some of these exotic stars aren't just strange celestial bodies? What if they hold the key to solving some of the deepest questions about the nature of reality itself? Right now, one of the biggest mysteries in physics is the nature of dark energy. We know that the universe is expanding at an accelerating rate, but we don't know why. The best explanation we have is dark energy, an unknown force that seems to be pushing space itself apart. But what if dark energy isn't just some invisible force spread throughout the universe? What if it's tied to exotic stars? Imagine that exotic stars generate some kind of repulsive force, something that counteracts gravity on a cosmic scale. If enough of these stars existed in the early universe, they could have influenced cosmic expansion in ways we don't yet understand. Maybe the presence of exotic matter created a pressure that pushed galaxies apart, setting the stage for the accelerated expansion we see today. And if that's true, then what happens when these exotic stars die? Do they collapse into something even stranger? Do they explode and release exotic particles that change the balance of the universe? Or do they slowly decay, releasing energy that fuels the mysterious force we call dark energy? But there's an even wilder possibility. What if exotic stars aren't just random cosmic phenomena? What if they are the result of a deeper structure in reality, something that connects the universe to other dimensions? Some theories suggest that exotic matter could be linked to extra dimensions, hidden layers of reality that exist alongside our own. If that's true, then exotic stars might not be just stars. They might be bridges between different parts of the universe, or even gateways to entirely different realms of existence. If exotic stars can bend space and time in ways we don't yet understand, they might be natural portals to other regions of the cosmos. Maybe they connect distant galaxies, allowing matter and energy to travel between them in ways we can't yet detect. Maybe they serve as anchors for wormholes, keeping these cosmic shortcuts stable and open. Or maybe they are something even stranger, objects that exist partially in our universe and partially in another, making them the first real evidence of parallel realities. But if that's true, then why haven't we found one yet? The answer might be that we simply haven't been looking in the right way. Right now, we classify stars based on their brightness, temperature, and composition. But what if exotic stars don't fit into these categories? What if they emit a type of radiation we don't normally search for? Think about it. There are already unexplained phenomena in astronomy that don't fit with what we know. Some objects emit bursts of energy that seem to defy the normal laws of physics. Others behave in ways that suggest they have unusual mass, density, or gravitational effects. What if these anomalies aren't just strange coincidences? What if they are the first hints that exotic stars are out there, waiting to be discovered? And if we do find one, what happens next? Do we try to send a signal? Do we attempt to study it up close? The moment we confirm the existence of an exotic star, everything changes. Suddenly, we have proof that the universe is even weirder than we imagined. Suddenly, we have a new frontier to explore, not just in space, but in the fundamental nature of reality itself. Imagine if we could harness the power of exotic stars. If these objects contain matter that defies normal physics, then they could be the key to technologies we can't even dream of yet. Maybe they hold the secret to limitless energy. Maybe they contain the ingredients for faster-than-light travel. Or maybe they could be used to manipulate gravity itself, allowing us to control space-time in ways that seem impossible today. But there's also a more unsettling possibility. What if exotic stars are dangerous? If they contain unstable forms of matter, then interacting with them could have unpredictable consequences. Maybe they generate gravitational waves strong enough to disrupt entire solar systems. Maybe they release particles that could alter the fundamental forces of the universe. Or maybe they are so alien to our understanding that even trying to study them could have unforeseen effects. And what if we're not the first to find them? If exotic stars exist, then any advanced civilization that came before us would have had to deal with them too. Maybe ancient alien societies discovered exotic stars long ago and learned how to use them, or how to avoid them. Maybe they built entire civilizations around them, using their strange properties to power interstellar empires. Or maybe they feared them, leaving behind warnings that we have yet to understand. The truth is, we don't know. But one thing is certain: if exotic stars are out there, then the universe is far more complex, far more mysterious, and far more incredible than we ever imagined. And if we ever find one, it won't just be a discovery. It will be a revelation, a moment in history that redefines what we know about the cosmos. The greatest mystery isn't just whether exotic stars exist. The greatest mystery is what they mean. What they tell us about the universe. And what they tell us about ourselves. If exotic stars exist, then their implications go far beyond just astronomy. They could redefine how we understand the fabric of the universe itself. Right now, everything we know about stars is built upon the idea that they follow the laws of physics as we currently understand them. But if exotic stars are real, then some of those laws might not be as unbreakable as we thought. One of the biggest questions is, how would these stars form? Normal stars are born from collapsing clouds of gas and dust, where gravity pulls everything inward until nuclear fusion ignites at the core. But exotic stars, if they exist, might have an entirely different formation process. Maybe they don't form from traditional matter at all. Maybe they emerge from the interactions of strange quantum forces, or even as remnants of an older, unknown universe that existed before ours. And if that's the case, then it raises a terrifying question: are exotic stars truly natural? Or could they be something else? Could they be artificial? It sounds like science fiction, but consider this: if exotic matter is as powerful and strange as we think, then any advanced civilization that understood it could potentially use it to create entirely new kinds of stars. Imagine a civilization so advanced that it doesn't just build cities or spacecraft, it builds stars. Maybe they found a way to manipulate exotic particles, assembling them into cosmic structures that behave in ways we can't yet comprehend. If that's true, then what we call an exotic star might not be a natural phenomenon at all. It might be evidence of a cosmic engineering project on a scale we can barely imagine. Perhaps these stars are artificial energy sources, designed to power vast interstellar civilizations. Or maybe they are containment structures, holding something inside that should never be released. But here's the most unsettling thought: if exotic stars are artificial, then where are their creators? If some ancient civilization built them, why don't we see any other traces of their existence? One possibility is that they're simply gone, wiped out by time, war, or some cosmic catastrophe. But another possibility is that they're still out there, watching. And what if exotic stars themselves are the reason we haven't made contact with advanced alien civilizations? Maybe these objects are so dangerous that any species that gets too close doesn't survive long enough to warn the rest of the universe. Maybe they produce effects that make entire regions of space uninhabitable. Or maybe civilizations that discover them become so obsessed with understanding them that they collapse under the weight of their own curiosity. But let's take it a step further. If exotic stars exist, then they could also be the key to understanding some of the biggest cosmic mysteries we've ever encountered. Could they be linked to fast radio bursts, those mysterious, intense pulses of energy that come from deep space with no clear explanation? Some scientists think fast radio bursts might be caused by neutron stars, But what if at least some of them are coming from exotic stars instead? Maybe these stars occasionally release bursts of exotic energy, creating signals that travel across the universe like cosmic beacons. And if that's true, then could we detect one? Could we build instruments that would allow us to find an exotic star based on the energy it emits? Right now, most of our telescopes are designed to detect normal forms of radiation, visible light, infrared, X-rays, gamma rays. But if exotic stars emit something completely different, then we might have to rethink how we search for them. Maybe they produce strange gravitational distortions that subtly warp the space around them. Maybe they emit particles that don't interact with normal matter in the usual way. Or maybe they exist in a kind of quantum superposition, flickering in and out of our reality in ways we don't yet understand. And if we do find one, what then? Do we send probes to study it? Do we try to harness its power? Or do we keep our distance, knowing that whatever secrets it holds might be too dangerous to uncover? Because there's one more possibility we haven't considered. What if exotic stars aren't just a rare cosmic phenomenon? What if they are far more common than we think, but we just haven't realized it yet? Think about it. The universe is vast, filled with trillions of galaxies and an uncountable number of stars. If even a small fraction of them are exotic, then the cosmos could be teeming with strange and powerful objects that we've never even noticed. Maybe they're hiding in plain sight, disguised as ordinary stars but with properties we've never taken the time to measure. Maybe they exist in parts of the universe we can't easily observe, on the edges of black holes, in the depths of intergalactic space, or even in regions where space-time itself behaves differently. And if we ever do uncover the truth about exotic stars, it won't just be an astronomical discovery. It will be a turning point in our understanding of reality itself. It will force us to rethink everything we thought we knew about the universe, from the laws of physics to the nature of existence itself. The question isn't just whether exotic stars exist. The real question is what they mean for us. What they reveal about the deepest secrets of the cosmos. And whether humanity is ready for the answers. If exotic stars exist, then they could represent a type of matter that has been theorized but never observed, something that exists outside the standard model of physics. This means that studying them might give us clues about the fundamental nature of reality itself. One of the biggest mysteries in modern physics is dark matter. We know it must exist because we see its gravitational effects, but we've never been able to detect it directly. Could exotic stars be made of dark matter? If so, they might be one of the first physical structures in the universe composed entirely of this elusive substance. If exotic stars are dark matter objects, they wouldn't behave like ordinary stars at all. They might not emit light in any recognizable way. They might be nearly invisible, detectable only through their gravitational pull on nearby objects. This could mean that our universe is filled with dark matter stars that have been hiding from us all along, completely undetectable by our traditional telescopes. But what if dark matter isn't just a passive substance? What if it can form structures, undergo reactions, or even ignite a form of exotic nuclear fusion? If that's the case, then exotic stars might be blazing away in the depths of space, powered by forces we don't yet understand. And if exotic matter exists, could it be harnessed for energy? The idea of exotic matter-powered spacecraft has been suggested before, especially in theories about faster-than-light travel. Some researchers believe that exotic particles could help stabilize a warp drive, creating a bubble of distorted spacetime that allows for faster-than-light movement without violating the known laws of physics. If exotic stars contain this kind of matter, then finding one could be the key to unlocking interstellar travel. Instead of struggling with chemical rockets and slow-moving spacecraft, we might be able to tap into the energy of an exotic star, using its strange properties to bend spacetime itself. But what if exotic stars are even stranger than we imagine? Could they exist outside of normal time? Some theories suggest that certain types of exotic matter could be linked to time dilation, or even time loops. If that's the case, then an exotic star might not just be a source of strange energy. It might be a place where time itself behaves differently. Imagine a star that flickers in and out of existence, appearing in different parts of the universe at different points in time. Or a star where the closer you get to it, the slower time moves, so that an observer on the surface might experience time at a fraction of the normal rate. This could have bizarre consequences for anything that interacts with the star. A spacecraft that gets too close might become trapped in a time loop, never escaping. Or an astronaut who ventures near might return to find that while they only experienced a few hours, thousands of years have passed for the rest of the universe. And if these stars exist, then could they be the answer to another cosmic mystery, the missing baryonic matter problem? We know that the visible universe doesn't account for all the normal matter that should exist based on our models. Maybe some of that missing matter isn't missing at all, it's just locked inside exotic stars, existing in a state that we haven't been able to detect. This could explain why certain parts of the universe seem to have strange gravitational anomalies. Maybe these anomalies aren't caused by dark matter alone, but by exotic stars lurking in the darkness, bending space-time in ways we don't yet understand. And if exotic stars exist, they could change everything we thought we knew about black holes. Right now, we assume that when a massive star collapses, it either forms a neutron star or a black hole. But what if there's a third possibility? What if, under certain conditions, the collapsing matter doesn't turn into a black hole, but instead condenses into an exotic state? These objects might mimic black holes in some ways, pulling in matter with extreme gravity, but without an event horizon. This could mean that some of the objects we've identified as black holes might not be black holes at all. They might be exotic stars, appearing almost identical to a black hole but with fundamentally different properties. If this is true, then it could explain some of the strange behaviors we've observed in black hole candidates. For example, some objects in deep space emit strange bursts of energy that don't quite fit with black hole models. Maybe these objects are actually exotic stars, occasionally releasing bursts of exotic radiation instead of simply pulling in matter like a traditional black hole. And here's the real mind-bending possibility: if exotic stars exist, they might not be bound by the same rules as normal stars. Maybe they can move in ways that defy our understanding of gravity. Maybe they can shift between dimensions. Maybe they can even act as gateways to other parts of the universe. What if exotic stars are connected to wormholes? Some theories suggest that certain types of exotic matter could stabilize a wormhole, preventing it from collapsing. If exotic stars are made of this matter, then they might naturally form wormholes, linking distant parts of the universe together. If that's the case, then these stars might be more than just cosmic anomalies. They might be the key to understanding the true structure of the universe itself. Maybe they connect different galaxies, or even different universes. Maybe they are cosmic portals, waiting for us to unlock their secrets. And if they are, then the implications are enormous. What if some of the unexplained cosmic signals we've detected aren't coming from alien civilizations, but from exotic stars sending bursts of energy across space-time? What if some of the unexplained gravitational anomalies we've observed are caused by hidden exotic stars, distorting reality in ways we haven't yet realized? And most importantly, what if someone else already knows about them? If an advanced civilization has discovered exotic stars, they might be using them in ways we can't even comprehend. Maybe they've harnessed their energy. Maybe they've used them to build interstellar highways. Or maybe they've learned something about them that made them decide to stay far away. Because if exotic stars exist, then there's one final question we have to ask: are they safe? Are they just rare cosmic objects? Or are they something far more dangerous? Something that civilizations discover, and then vanish before they can warn anyone else? Maybe exotic stars are the reason we don't see evidence of alien civilizations. Maybe they're not just strange cosmic objects, but cosmic traps, luring in anyone who gets too close, drawing them into a gravitational abyss from which they never return. Or maybe they're the key to everything. Maybe they hold the answers to the deepest questions we've ever asked about the universe, waiting for us to find them. The only question is, will we? The mystery of exotic stars isn't just a question of physics, it's a question of how reality itself works. If such stars exist, they could redefine our entire understanding of matter, energy, space, and time. But here's where things get even stranger. If these stars are truly made of exotic matter, their properties might be so different from anything we've ever seen that even getting close to one could have unpredictable effects. Imagine a spacecraft approaching an exotic star, expecting to find something similar to a neutron star or black hole. But instead, as it gets closer, time itself starts behaving differently. Instruments begin giving readings that make no sense. The star seems to shift in and out of visibility, flickering between dimensions. What if exotic stars don't just exist in our universe, but in multiple universes at once? Some physicists have suggested that exotic matter could be linked to theories of the multiverse. If exotic stars are made of particles that exist in a higher dimensional space, they might not be fully bound to our reality. They could be leaking into parallel universes or even acting as anchors that hold different realities together. If this is true, then finding an exotic star might not just be a matter of physics. It could be the first step toward proving the existence of other universes. And if these stars exist, they might explain some of the strangest cosmic phenomena we've observed, like fast radio bursts or unexplained gamma-ray flashes. Could these bursts of energy be moments when an exotic star briefly interacts with our universe? Maybe these stars don't behave like normal stars at all. Maybe they pulse in and out of existence, appearing only when the conditions are just right. And if exotic stars are connected to the fabric of reality itself, then they might have a direct link to dark energy, the force that is driving the expansion of the universe. We still don't know what dark energy is or where it comes from, but what if exotic stars are part of the answer? If these stars exist outside the normal rules of physics, they might be acting as hidden sources of energy that influence the large-scale structure of the cosmos. They might be pulling and stretching space-time, causing galaxies to drift apart faster than we expect. And if we could find a way to harness this energy, it could be the biggest breakthrough in human history. We could potentially tap into a power source unlike anything we've ever seen, a force that isn't limited by the same rules as normal matter. But what if there's a reason we haven't found these stars yet? What if exotic stars don't just exist in remote corners of the universe, but right here, hidden in plain sight? Some researchers have suggested that there could be exotic stars within our own galaxy, disguised as ordinary stars or even masquerading as black holes. If that's true, then our entire understanding of astrophysics might be built on an incomplete picture of reality. And if exotic stars exist in our galaxy, then there's another chilling possibility. What if one of them is close enough to affect us? What if there's an exotic star lurking somewhere nearby, influencing the fabric of space-time in ways we haven't yet realized? Could it be responsible for some of the unexplained gravitational anomalies we've detected in deep space? Could it be distorting the movement of nearby objects in ways that don't fit our models? And most importantly, if one of these stars is close to us, could it pose a danger? We have no idea what would happen if Earth were to drift too close to an exotic star. Would it pull us into a different dimension? Would it stretch time around us, causing strange distortions in history? Or could it do something even more unthinkable, rewrite the very laws of physics in our part of the universe? If exotic stars are real, then we might be standing on the edge of a discovery that could change everything. But the real question is, are we ready to find out? If exotic stars exist, they could challenge everything we think we know about the fundamental structure of reality. The idea that entire stars might be composed of exotic matter isn't just a wild theoretical concept. It could be the missing link that explains some of the biggest mysteries in physics, from dark matter to the expansion of the universe to the nature of space-time itself. But the more we dig into this possibility, the more unsettling it becomes. Because if such stars do exist, they might not behave like anything we've ever seen before. They could be invisible, lurking in the depths of space, detectable only by their bizarre gravitational effects. Or they could be something even stranger, objects that don't just exist in our universe, but across multiple dimensions at once. One of the biggest unsolved problems in physics is the question of dark matter. We know that there is far more mass in the universe than we can see. Galaxies rotate as if they are surrounded by an enormous amount of unseen matter, and gravitational lensing shows that something is warping space-time on a colossal scale. But despite decades of searching, we have never been able to detect dark matter directly. What if exotic stars are the answer? Instead of being scattered clouds of weakly interacting particles, what if dark matter has actually collapsed into massive, hidden stars that exist in an exotic state of matter beyond anything we currently understand. If these objects exist, then they could be warping the fabric of the cosmos in ways we've never realized. And here's where things get even weirder. If exotic stars are made of dark matter, they wouldn't behave like normal stars at all. Instead of shining brightly like the sun, they might be almost completely invisible, radiating little or no light. They could be scattered throughout the galaxy, forming a hidden network of massive, gravitationally powerful objects that we've never been able to detect. In fact, some scientists have already speculated that certain gravitational anomalies, such as unexplained variations in the movement of stars or odd distortions in deep space observations, could be signs of these invisible stars. But what if these objects aren't just dark, but also incredibly strange in how they interact with reality? Some theories suggest that certain types of exotic matter could have negative energy, or even negative mass. If this is the case, then exotic stars might not just be weird, they could be outright impossible according to our current understanding of physics. And yet, if they exist, they could explain some of the biggest mysteries in cosmology, including the accelerating expansion of the universe. We still don't know why the universe is expanding at an ever-increasing rate. The current leading theory is dark energy, an unknown force that is pushing space apart. But what if the answer isn't an abstract force, but rather the presence of exotic stars? If some regions of the cosmos contain massive objects made of exotic matter with negative mass, they might be exerting a repulsive gravitational effect, causing space itself to stretch outward. In other words, the expansion of the universe might not be driven by a mysterious form of energy, but by the strange properties of these hidden stars. And if exotic stars are real, they could also provide an entirely new perspective on the nature of black holes. Right now, we assume that when a massive star collapses, it forms either a neutron star or a black hole. But what if, under the right conditions, the collapsing matter doesn't form a singularity but instead transitions into an exotic state? These objects might mimic black holes in many ways, exhibiting extreme gravitational effects, but without an event horizon. In other words, some of the objects we currently classify as black holes might not actually be black holes at all. They could be exotic stars masquerading as singularities. If this is true, then it could solve one of the biggest paradoxes in modern physics, the information paradox. According to Einstein's general relativity, anything that falls into a black hole is lost forever. But according to quantum mechanics, information can't simply disappear. This contradiction has puzzled scientists for decades. But if exotic stars exist, they could offer a solution. Instead of matter being lost inside a singularity, it could be entering an exotic state of existence, preserving the information in ways we don't yet understand. And then there's an even more mind-bending possibility. What if exotic stars are linked to other universes? Some theories suggest that certain types of exotic matter could be connected to higher dimensions or parallel realities. If that's the case, then these stars might not just be objects within our universe, but cosmic gateways that connect different parts of the multiverse. Imagine an exotic star that acts as a bridge between different realities, allowing energy and even matter to move between universes. If this is true, then some of the unexplained cosmic signals we've detected, such as fast radio bursts or mysterious flashes of gamma rays, might not be coming from distant galaxies, but from exotic stars momentarily interacting with our reality. And if such stars exist, they might not be rare. They could be hidden throughout the universe, forming an unseen cosmic web that connects different regions of space in ways we never imagined. Some might even be close to us, lurking within our own galaxy. In fact, there have been suggestions that certain anomalous objects observed in deep space, such as stars that seem to flicker inexplicably or gravitational distortions that don't match predictions, could be evidence of these exotic phenomena. But if exotic stars are real, they raise an even bigger question. What happens if we find one? Would it be stable, or could it collapse into something even stranger? Could an exotic star become so massive and dense that it collapses into a new form of singularity? One that doesn't just trap matter, but bends the fundamental laws of physics themselves? Could it create a tear in the fabric of space-time, opening a rift that leads to the unknown? And if an advanced civilization has already discovered these stars, what have they learned? Have they harnessed their energy? Have they used them to travel across the cosmos? Or have they discovered something so terrifying that they chose to stay away? If exotic stars are connected to the deepest secrets of the universe, then they might not just be strange cosmic anomalies. They might be cosmic warning signs, objects so powerful and unpredictable that even the most advanced civilizations dare not approach them. Because if these stars exist, then there is one final question we have to ask: are they safe? Are they simply strange but harmless objects drifting in the void? Or are they something far more dangerous, something that has the power to reshape reality itself? If an exotic star were to drift too close to our solar system, what would happen? Would its gravitational effects distort our orbit? Would its exotic radiation alter the very fabric of space-time around us? Or could it do something even more unthinkable, cause the laws of physics in our region of the universe to change, rewriting the fundamental constants that govern existence? We don't know the answers yet. But one thing is certain: if exotic stars exist, they could be the key to unlocking some of the greatest mysteries of the cosmos. They could hold the secrets to dark matter, dark energy, black holes, and even the nature of the multiverse. But they could also be the most dangerous objects in existence, capable of bending reality in ways we don't yet comprehend. The question is, will we find them before they find us? If exotic stars are real, they might already be shaping the universe in ways we don't yet understand. These objects could be relics of a past cosmic era, formed under conditions that no longer exist, or they could be emerging even now in hidden corners of the universe, waiting to be discovered. But the deeper we go into this possibility, the stranger it gets. Because if entire stars can be made of exotic matter, it means that the fundamental building blocks of reality are far more complex than we ever imagined. For a moment, imagine a star that doesn't behave like the ones we know. It doesn't shine in the visible spectrum, doesn't generate heat in the way our sun does, and doesn't even interact with normal matter in a conventional way. Instead, it exists in a strange quantum state, radiating energy in forms we've never encountered, bending space-time in ways that defy our understanding. Some physicists speculate that certain types of exotic matter could create effects similar to what we see with gravitational lensing, but in ways far more extreme. These stars might not just bend light, they could distort reality itself. One of the strangest properties that exotic matter could have is negative mass. In our everyday experience, mass is always positive. An object with mass resists acceleration, it has inertia. But if something had negative mass, it would behave in the exact opposite way. If you pushed it, instead of moving away from you, it would move toward you. If exotic stars contain negative mass material, they could repel normal matter instead of attracting it. They might create vast regions of space where the usual laws of physics break down, forming areas where gravity behaves in ways that seem impossible. And what if negative mass stars exist in large numbers? Instead of being rare, isolated anomalies, they could be part of an entire hidden structure of the cosmos. Some theories suggest that dark matter could actually be a vast network of negative mass objects. If this is true, then exotic stars might not just be a possibility, they might be a fundamental part of the universe, forming an unseen backbone that has been influencing cosmic evolution from the very beginning. But there's an even deeper mystery here. If exotic stars exist, they could be part of something much bigger, an unknown force shaping the universe in ways we haven't even begun to comprehend. Right now, one of the greatest puzzles in physics is the accelerating expansion of the cosmos. We assume that dark energy is responsible, but what if that's not the whole story? If exotic stars exist, they could be acting as cosmic repulsors, pushing space apart through their unique gravitational effects. In other words, the force that is stretching the universe might not be a mysterious energy field. It might be the influence of exotic matter on a vast, cosmic scale. And here's where things get really unsettling. If these stars are influencing the expansion of the universe, could they also be affecting time itself? Some physicists have proposed that certain types of exotic matter could warp time in ways that seem impossible. If exotic stars have these properties, they might be creating localized distortions in time, causing it to flow at different rates in different regions of space. This could explain some of the anomalies we've observed in distant galaxies, places where time appears to be moving faster or slower than expected. But what if these time distortions aren't just localized? What if exotic stars are connected to something even more extreme, wormholes? The idea that space-time can fold in on itself to create shortcuts across the universe has long been a favorite of science fiction, but some theories suggest it might actually be possible. If exotic matter is real, then stable wormholes could exist, and exotic stars might be the key to finding them. Some researchers have even suggested that certain unexplained cosmic signals, such as fast radio bursts, could be the result of objects passing through these hidden wormholes. If this is true, then exotic stars might not just be strange, distant phenomena. They could be gateways to other parts of the universe, or even other dimensions. And that raises an even bigger question: what happens if something else is using them? If exotic stars can create stable wormholes, then they could be natural pathways through space-time. Could an advanced civilization have already discovered this? Could they be using these exotic structures to travel across the cosmos in ways we can't even imagine? If so, then the signals we've been detecting might not be random cosmic noise. They might be messages, or evidence of something moving through the universe in ways we don't yet understand. And what if some of these exotic stars are more than just natural objects? If an advanced civilization had access to exotic matter, they might have created artificial stars, objects engineered to harness the bizarre properties of the cosmos itself. These structures might be capable of doing things that seem completely impossible, such as manipulating gravity, bending space-time, or even altering the fundamental constants of physics. But here's the truly terrifying part: if exotic stars can do all of this, then what happens if one of them gets too close to us? Could a passing exotic star disrupt the stability of our solar system? Could its gravitational effects cause unpredictable consequences, pulling planets out of their orbits or triggering catastrophic shifts in space-time? And if exotic matter has the potential to interact with normal matter in strange ways, could a collision between an exotic star and a regular one create a disaster on an unimaginable scale? We don't have the answers yet. But the fact that we're even asking these questions means that we're on the edge of discovering something truly profound. If exotic stars are real, they could change everything we thought we knew about the universe. They could reveal secrets that have remained hidden since the dawn of time. They could show us the true nature of dark matter, the expansion of the cosmos, and even the fabric of reality itself. But they could also be the greatest cosmic mystery of all, objects so strange, so powerful, and so beyond our understanding that they redefine what we believe is possible. And if that's the case, then the search for exotic stars might not just be a scientific quest. It might be the first step toward unraveling the deepest secrets of the universe. If exotic stars exist, their implications go far beyond just being another type of celestial body. They could represent an entirely new class of physics that we haven't yet grasped. The known laws of the universe are built on well-defined forces: gravity, electromagnetism, and the nuclear interactions that govern atoms. But exotic matter, if it exists in large enough quantities to form stars, suggests there are forces at play that don't behave the way we expect. It could mean that the universe has hidden layers of reality we haven't yet uncovered. Imagine for a moment that exotic stars don't just exist, they're abundant. What if vast portions of the cosmos are filled with these strange objects, hidden from us because they don't emit light in a way that our telescopes can detect? Some theorists have suggested that exotic stars might exist in dark sectors of the universe, regions where normal matter is scarce, and exotic physics dominates. These could be areas where space-time itself behaves differently, where the rules we take for granted break down. If such regions exist, they could explain many of the biggest mysteries in astronomy. Take, for example, the strange behavior of galaxies. The outer edges of galaxies rotate much faster than expected, as if there's some unseen mass holding them together. We attribute this to dark matter, but what if that missing mass isn't some invisible particle? What if it's hidden exotic stars, objects that don't interact with light the way normal stars do? If so, we might already be looking at the effects of exotic matter on a cosmic scale. We just haven't recognized it yet. But here's where things get even more interesting. If exotic stars exist, they could be relics from an earlier era of the universe, remnants of conditions that no longer exist today. Some physicists speculate that in the moments after the Big Bang, the universe went through rapid transitions, where different types of matter formed and disappeared as the cosmos cooled. If exotic matter formed in those early moments, some of it might have persisted, trapped in a stable form that allowed it to clump together into stars. If that's true, then finding an exotic star would be like looking back in time billions of years, seeing a piece of the universe that shouldn't exist anymore. It would be like discovering a lost chapter of the cosmos, one that could tell us what the early universe was really like. And if these objects are scattered throughout the universe, they might even act as clues to understanding what happened before the Big Bang itself. But there's another possibility, one that's even more unsettling. What if exotic stars aren't relics of the past, but precursors to something in the future? What if they're not just strange objects, but signals of an upcoming cosmic shift? Some cosmologists believe the universe might not stay the way it is forever. It could undergo another transformation, where the fundamental forces change once again. If exotic matter plays a role in that process, then these stars might be signs that the universe is preparing for its next phase, a shift in physics itself, one that could reshape everything we know. And if that's the case, then the existence of exotic stars isn't just a scientific curiosity. It's a warning. It means that the universe is far more dynamic and unpredictable than we ever imagined, and that the reality we take for granted might not be as stable as it seems. If these stars hold the key to unlocking a deeper understanding of the cosmos, then studying them isn't just about curiosity, it's about survival. Because if we don't understand them, we might not see the next great cosmic transformation coming until it's too late. The search for exotic stars is more than just another astronomical mystery. It's a glimpse into a hidden layer of the universe, one that could rewrite everything we thought we knew about reality. And if they exist, they might not just be out there, in some distant corner of space. They could be closer than we think, waiting to be discovered, ready to change our understanding of the cosmos forever. If exotic stars truly exist, the next question is, how would we find them? Unlike normal stars, which shine brightly due to nuclear fusion, exotic stars might not emit light in any familiar way. If they are composed of strange quark matter, dark matter, or other unknown particles, they could be nearly invisible to traditional telescopes. This means we might have to rethink our approach to detecting them. Instead of looking for visible light, we might need to search for unusual gravitational effects, unexpected bursts of radiation, or even distortions in space-time itself. One promising method involves gravitational lensing. This occurs when a massive object bends the light from something behind it, creating a magnifying effect. If exotic stars exist, their unique mass distribution could cause gravitational lensing patterns that don't match anything we've seen before. They might warp light in a way that hints at their unusual composition, revealing their presence without needing them to emit any detectable radiation. Another possibility comes from gravitational waves, the ripples in space-time caused by massive objects colliding. Normal neutron stars and black holes produce these waves when they merge, and we've already detected several such events using observatories like LIGO and Virgo. But what if some of the signals we've picked up weren't from normal neutron stars or black holes? What if some were caused by exotic stars colliding? If exotic matter behaves differently under extreme pressure, these mergers could produce gravitational wave signatures unlike anything we've seen before. There's also the question of how exotic stars interact with their surroundings. If they exist, they might occasionally come into contact with normal matter, perhaps by drifting through a dense gas cloud or by having a companion star orbiting nearby. In such cases, the interaction between exotic matter and normal matter could produce strange and unpredictable effects. Some theorists suggest that exotic stars could cause bursts of gamma rays, flashes of X-rays, or even unexplained energy emissions that don't match standard astrophysical processes. But what if exotic stars are even stranger than we think? Some speculative theories suggest they might not just be passive objects floating in space. Instead, they could be active in ways that challenge our understanding of what a star can be. For example, what if exotic stars aren't just made of unusual matter, but actually generate new forms of physics around them. Some models propose that exotic matter could alter the vacuum of space itself, creating regions where the laws of physics behave differently. If that's the case, then an exotic star might not just be an object, it could be a gateway to an entirely new state of reality. And then there's the ultimate mystery: if exotic stars exist, could they play a role in the evolution of the universe itself? Some theories suggest that exotic matter could be linked to the fate of the cosmos, possibly influencing the way dark energy behaves. Dark energy is the mysterious force causing the universe to expand at an accelerating rate, and we still don't fully understand it. If exotic stars contain hints about the nature of dark energy, they could help us determine whether the universe will continue expanding forever, slow down, or even collapse in the future. Big crunch. There's even a possibility that exotic stars could be tied to the multiverse hypothesis, the idea that our universe is just one of many. If exotic matter behaves differently from normal matter, it might be a remnant of physical laws from another universe, a leftover fragment from a cosmic event beyond our own Big Bang. If so, then discovering an exotic star wouldn't just be about finding a new type of celestial body. It would be proof that our universe isn't alone. So the question remains, are these exotic stars real, or are they just theoretical constructs? Right now, we don't have direct evidence of their existence, but that doesn't mean they aren't out there. Science has a long history of discovering things that were once considered purely hypothetical. Black holes were once just a mathematical possibility, and now we have images of them. Neutron stars were once an abstract concept, and now we study them in detail. Exotic stars could be the next great discovery, waiting for us to find them, hidden in the vastness of space, challenging everything we think we know. If exotic stars exist, they could force us to rethink not only our understanding of stellar evolution, but also the very fabric of the universe itself. The standard life cycle of a star follows well-understood principles. A cloud of gas collapses under gravity, nuclear fusion ignites in the core, and the star either burns steadily for billions of years or, if it's massive enough, ends in a dramatic supernova. But exotic stars might not follow these rules at all. For one, their formation process could be completely different. While normal stars are built from hydrogen and helium, exotic stars might form from matter that doesn't interact through the electromagnetic force. That means they wouldn't coalesce the same way normal stars do. Instead of forming in nebulae, they might emerge under conditions we haven't yet imagined, perhaps in the dense centers of galaxies, near black holes, or even in the aftermath of cosmic inflation in the early universe. If that's the case, then the presence of exotic stars could indicate the existence of an entirely different stellar ecosystem, one that has been invisible to us until now. There could be hidden constellations made entirely of these strange objects, drifting through space unseen, shaping galaxies in ways we haven't yet realized. If we could detect them, we might uncover a second, parallel form of astrophysics operating alongside the one we know. And what happens when an exotic star reaches the end of its life? Normal stars either collapse into white dwarfs, neutron stars, or black holes, depending on their mass. But an exotic star's fate is harder to predict. If it's made of strange quark matter, it might not collapse at all. It could persist indefinitely in a stable form, defying the normal aging process. If it's made of dark matter, it might dissipate into space without a trace. Or if it's governed by unknown forces, its death could trigger an event we can't yet comprehend, perhaps an explosion that produces entirely new particles, or a transformation that alters space-time itself. One radical idea is that exotic stars could be connected to primordial black holes that formed in the first fractions of a second after the Big Bang. If some regions of the early universe were dense enough, they might have created not only black holes but also exotic stars, composed of whatever strange material existed in those extreme conditions. If that's true, then finding an exotic star could give us a direct link to the very first moments of cosmic history, offering clues about the universe's origins that we can't get from any other source. And then there's the possibility that exotic stars aren't just objects, but cosmic engines. If they interact with dark energy, or other unknown forces, they could be actively shaping the large-scale structure of the universe. Some theorists have proposed that exotic matter could be responsible for the acceleration of the universe's expansion. If so, then exotic stars might not just be passive relics. They could be the driving force behind some of the most fundamental processes in the cosmos. But what if exotic stars aren't just rare, scattered anomalies? What if they're common, but we just haven't been looking for them in the right way? If we assume that exotic matter exists in large quantities, then it's possible that entire galaxies or even galaxy clusters could be filled with exotic stars, forming a hidden cosmic architecture that we've never seen. In that case, our view of the universe is incomplete. We're only seeing the part that interacts with normal matter, while an entirely different reality exists just beyond our perception. If that's true, then the discovery of exotic stars could be the first step toward uncovering an entire hidden universe. It would mean that the cosmos is far richer and stranger than we ever imagined, filled with unknown forces, unseen structures, and new kinds of physics that could revolutionize our understanding of existence itself. And if we ever manage to directly observe one of these stars, it could be the key to unlocking the deepest mysteries of the universe, revealing not just what's out there, but what reality itself is truly made of. If exotic stars are out there, one of the biggest challenges we face is figuring out how to prove their existence. The problem is that they wouldn't behave like ordinary stars. We can't rely on the same observational techniques that we use to study main sequence stars, white dwarfs, or neutron stars. Instead, we would need to identify indirect evidence, anomalies that don't fit within the framework of conventional astrophysics. One possible way to detect exotic stars is by looking for objects with unusual mass-to-radius ratios. Neutron stars are already incredibly dense, with masses greater than the Sun packed into a sphere just a few kilometers wide. But exotic stars could be even denser, meaning they could have masses similar to neutron stars but occupy even smaller volumes. If we find objects that are denser than what neutron star models predict but aren't black holes, we might be looking at exotic stars. Another clue could come from temperature readings. If exotic stars are composed of strange quark matter, they might cool differently than neutron stars. Instead of radiating heat in a predictable way, they could exhibit unusual temperature variations that don't match standard cooling models. Some exotic matter theories suggest that quark stars, for example, could have strange thermal properties that cause them to emit bursts of radiation or maintain unexpectedly high temperatures for long periods. But perhaps the most intriguing possibility involves the detection of unusual gravitational wave signals. When two neutron stars collide, they generate gravitational waves that can be detected by observatories like LIGO and Virgo. If exotic stars exist, their collisions should also produce gravitational waves. But the signal might look completely different. For example, if a strange quark star collides with a neutron star, the event might release an unexpected pattern of waves, revealing the presence of exotic matter. It's also possible that exotic stars could interact with dark matter in ways we haven't considered. Some theories propose that dark matter could accumulate inside neutron stars, gradually transforming them into exotic stars over time. If that's the case, we might be able to detect neutron stars that are slowly changing in unexpected ways, perhaps gaining mass without an obvious energy source or exhibiting strange rotational behavior. And then there's the question of how exotic stars might evolve over cosmic timescales. Could they merge to form even stranger objects? Could they decay into new types of particles? If exotic matter has properties beyond the standard model of physics, it might undergo processes that don't exist in normal matter. This means that exotic stars might not just be static objects. They could be dynamic, changing in ways that challenge our understanding of stellar evolution. The implications of discovering an exotic star would be profound. If we confirm their existence, it would mean that the universe contains forms of matter that are entirely different from anything we've encountered. It could redefine our understanding of fundamental forces, challenge existing models of particle physics, and even provide insights into the nature of dark matter and dark energy. And beyond the scientific implications, there's the deeper philosophical question: what does it mean if stars can exist in forms we never imagined? For most of human history, we assumed that the universe was made up of familiar elements: hydrogen, helium, and the other building blocks of normal matter. But if entire stars can be composed of exotic particles, then the cosmos is far stranger than we ever thought. It means that we've only scratched the surface of what's possible, and that the universe is hiding layers of reality that we have yet to uncover. This realization forces us to confront the limits of our knowledge. How much of the universe are we truly seeing? How much remains hidden, waiting for us to discover it? If exotic stars exist, they could be the key to answering these questions, revealing a hidden world that has been invisible to us until now. And once we find them, we might have to rewrite everything we thought we knew about the nature of existence itself. If exotic stars exist, their implications stretch far beyond just stellar physics. They could hold the key to understanding the very nature of the universe at its most fundamental level. Imagine if these stars are not just cosmic anomalies but vital components of a deeper, hidden structure of reality, one that operates on principles we have yet to comprehend. If matter can exist in forms completely alien to what we observe in normal stars, then the laws of physics, as we know them, might only be a small part of a much grander framework. This could mean that for all our advancements, we are still barely scratching the surface of what the cosmos is truly made of. It forces us to reconsider what we mean when we talk about the known universe. How much of what we see is just a fraction of a much larger, more complex reality? What if the matter we are familiar with is just one expression of a broader set of physical laws, and exotic stars are glimpses into this hidden domain? One of the most profound implications of exotic stars would be their connection to dark matter. Scientists estimate that dark matter makes up about 85% of the total matter in the universe, yet we have never directly detected it. What if some of this unseen mass is locked inside exotic stars, hiding in plain sight? If dark matter interacts with itself in a way that allows it to form dense stellar objects, then exotic stars might not be as rare as we think. They might be scattered throughout the cosmos, blending into the fabric of galaxies while remaining invisible to our telescopes. In this scenario, entire regions of the universe could be populated by exotic stars, forming dark constellations that we can't see. What if the Milky Way itself has an entire counterpart made of these mysterious objects, an invisible shadow galaxy coexisting with our own? The idea may sound like science fiction, but if exotic stars can exist, then so can entire celestial structures built from materials we have yet to understand. Even more mind-boggling is the possibility that exotic stars could act as bridges to new physics. If they are composed of unknown particles or forces, studying them could provide the first direct evidence of physics beyond the standard model. Right now, our best theories describe how the fundamental particles interact, but there are still many unanswered questions. Why gravity is so weak compared to other forces, why the universe contains more matter than antimatter, and why dark energy is causing cosmic expansion to accelerate. Exotic stars might hold the answers. If they contain forms of matter that don't fit within our current understanding, they could offer clues about forces that operate outside the realm of known physics. Perhaps their existence could even help us uncover a long-sought theory of everything, a unified framework that explains all fundamental interactions in nature. But here's where things get even stranger. What if exotic stars are not just a product of rare cosmic conditions but something far more fundamental? Some physicists speculate that the early universe was a place where exotic matter was far more common, and if so, exotic stars could be remnants of that primordial era. This would mean that rather than being oddities, they are actually ancient fossils of the universe's earliest moments, formed under conditions that no longer exist today. If that's the case, then discovering an exotic star would be like finding a preserved relic from the Big Bang itself, a living artifact that has persisted for billions of years. What if some of these stars are older than the known universe as we understand it? Could they have formed in a previous cosmic cycle, surviving a past version of reality before being carried over into our current one? Another incredible possibility is that exotic stars could be tied to black holes in ways we haven't yet considered. Black holes are already some of the most mysterious objects in the universe, places where gravity is so strong that nothing, not even light, can escape. But what if exotic stars are the missing link between normal matter and black holes? Perhaps they represent an intermediate stage, a form of matter so dense that it sits on the very edge of collapsing into a singularity. If so, studying them could reveal entirely new insights into how matter behaves under extreme conditions, helping us understand what really happens at the event horizon of a black hole. Even more astonishing, what if exotic stars could temporarily stabilize themselves at the brink of collapse, defying the normal rules of physics? If such objects exist, they could offer a completely new perspective on what it means for matter to exist in the first place. Then, there's the possibility that exotic stars are not entirely natural at all. What if, instead of being purely astronomical phenomena, they are the result of advanced technology, perhaps even artificial constructs designed by a highly advanced civilization? If an alien species had a deep understanding of exotic matter, they might have learned how to harness it to create artificial stars, using them as power sources, cosmic beacons, or even as elements of a massive interstellar network. This would change everything. Instead of viewing these objects as rare astrophysical curiosities, we would have to consider the possibility that they are engineered, intentionally placed in the universe for purposes we cannot yet comprehend. If this is true, then finding an exotic star could be our first real evidence of intelligent life beyond Earth, proof that somewhere out there, beings exist who have mastered forces beyond our imagination. If exotic stars are out there, we need to figure out how to find them. Traditional telescopes might not be enough. Since these stars wouldn't emit light in the same way as normal stars, we would have to rely on indirect methods, looking for anomalies in gravitational waves, detecting unexplained excesses of certain particles, or spotting deviations in stellar orbits that suggest the presence of unseen mass. But what if the key to finding them isn't looking outward, but looking inward? If exotic matter exists, small amounts of it might be found right here on Earth, perhaps hidden within cosmic rays or buried in deep-sea sediments. If we can identify even a single particle of exotic matter in a controlled environment, it could serve as a blueprint for what to look for in deep space. And what if we eventually do confirm that exotic stars are real? How would that change our understanding of our place in the universe? For centuries, we have built our knowledge of the cosmos based on what we can observe with our eyes and instruments. But the discovery of exotic stars would prove that there is an entire hidden side of reality that we have never seen. It would mean that the universe is filled with secrets we have yet to uncover, and that the story of the cosmos is far from complete. It could push humanity into a new era of exploration, one where we are not just searching for planets, black holes, or galaxies, but for an entirely new class of celestial objects, objects that defy our expectations and challenge everything we thought we knew. The search for exotic stars is more than just a scientific quest, it is a journey into the unknown. Whether they are made of strange quark matter, dark matter, or something beyond our current understanding, their discovery would be one of the most significant breakthroughs in the history of physics. They could teach us about the fundamental nature of matter, reveal the presence of dark forces that shape the universe, and perhaps even provide the first hints of an advanced cosmic intelligence. If they are out there, waiting to be found, then the universe is far stranger and more wondrous than we ever imagined. And the question we must ask ourselves is, are we ready to uncover the secrets they hold? There's a deep irony in our search for exotic stars. If they exist, they might be some of the most important objects in the universe, yet they could also be nearly impossible to find. Imagine trying to spot something that emits no visible light, doesn't behave like normal matter, and might even be composed of particles that interact only weakly with the known forces of nature. It would be like trying to detect a ghost in a crowded city, something that influences its surroundings in subtle ways but remains unseen itself. And yet, scientists are not giving up. They believe that the existence of exotic stars is not just a theoretical curiosity, but a genuine possibility that could reshape physics. If we find just one, it could lead to a revolution in our understanding of matter, gravity, and even the origins of the universe itself. But here's where things get even stranger. What if we've already found evidence of exotic matter but just didn't recognize it? There have been unexplained cosmic signals, strange gravitational anomalies, and even observations of stars that don't quite behave the way they should. Could it be that some of these anomalies are actually the footprints of exotic stars? Consider the fast radio bursts, FRBs, that have baffled astronomers for years. Mysterious pulses of energy that come from deep space and last only milliseconds. Some scientists have suggested that these bursts could come from highly magnetized neutron stars. But what if they are actually coming from something even more unusual? Could they be signals emitted by exotic stars undergoing strange, high-energy processes? If so, then exotic stars might not just be lurking in the distant cosmos. They might be sending us signals right now. Another possibility is that exotic stars could be hiding in plain sight, disguised as objects we think we already understand. Neutron stars and black holes are some of the most extreme objects in the universe, and they are often assumed to be made of conventional matter. But what if some of these objects are actually exotic stars masquerading as something more familiar? Imagine if a fraction of the neutron stars we've detected are not neutron stars at all, but rather dense objects composed of strange matter or even dark matter. The only way to distinguish them would be through subtle differences in their behavior, differences that we may not have noticed yet. This raises an astonishing possibility. The exotic matter we are searching for might already be mapped in our star catalogs, but we just haven't realized what we're looking at. But let's go even further. What if exotic stars are not just objects within the universe but are somehow linked to the fundamental structure of reality itself? Some physicists believe that exotic matter could play a role in forming cosmic strings, hypothetical defects in spacetime that stretch across the universe like invisible threads. If exotic stars are connected to these structures, they might not be just celestial bodies but rather nodes in a vast cosmic network, linking different parts of the universe in ways we can't yet comprehend. Could it be that exotic stars act as anchors for these hidden structures, stabilizing the fabric of spacetime itself? If so, then their existence wouldn't just challenge our understanding of astrophysics. It would force us to rethink the very nature of space and time. Then there's the mind-bending idea that exotic stars could be linked to extra dimensions. String theory, one of the leading candidates for a theory of everything, suggests that additional dimensions exist beyond the three spatial dimensions and time that we experience. Most of these dimensions are thought to be hidden, curled up at microscopic scales where they are undetectable. But what if exotic matter has the unique ability to interact with these extra dimensions? If that's the case, then exotic stars might be more than just unusual celestial objects. They might be gateways to hidden layers of reality. Perhaps they are not just stars as we understand them, but rather objects that straddle multiple dimensions, existing partly in our universe and partly in a realm beyond our perception. And if exotic stars exist in extra dimensions, what else might be hiding there? Could entire galaxies made of exotic matter exist beyond our reach, slipping between the cracks of our known universe? If so, then the cosmos might be far larger and stranger than we ever imagined. What if our Milky Way has a shadow counterpart, an entire dark galaxy composed of exotic stars orbiting alongside us but completely undetectable except through its gravitational pull? If we could learn to detect these hidden objects, it would open an entirely new frontier in astronomy, one that reveals an invisible universe lurking alongside our own. But what if exotic stars are more than just relics of exotic physics? What if they are alive in some way? It sounds impossible, but think about it. Life as we know it is built on complex interactions of matter and energy. If exotic stars contain unknown particles or forces, could they support forms of intelligence that exist on a level we can't even comprehend? Perhaps inside the heart of an exotic star, complex interactions between strange matter and dark forces give rise to structures beyond our imagination, self-organizing systems that function like a form of cosmic consciousness. If such a thing were possible, then exotic stars might not just be astronomical objects, but something more akin to cosmic minds, intelligent entities that exist on scales beyond anything we have ever considered. And what if they are trying to communicate? If exotic stars are truly alien in nature, they might operate on principles so different from our own that we would never recognize their signals. Perhaps they don't emit radio waves, but rather manipulate spacetime itself to send messages. If that's the case, then we might have been receiving signals from exotic stars for decades but simply lack the means to interpret them. Could gravitational waves, normally thought to come from colliding black holes, actually be the echoes of exotic stars sending signals across the cosmos? If we could decode these signals, what would they tell us? Would they reveal a higher order of physics, something that transcends our current understanding? Would they offer a glimpse into the true nature of reality, showing us that the universe is not just a collection of dead matter, but a vast, interconnected system of intelligence? And if exotic stars are communicating, are they speaking only to us, or are they part of a greater cosmic conversation, one that has been happening for billions of years, waiting for us to finally listen? If exotic stars exist, then they are not just another category of celestial objects. They are keys to unlocking some of the deepest mysteries of the universe. They could hold the answers to dark matter, extra dimensions, the origins of the cosmos, and even the nature of intelligence itself. The question is not just whether they exist, but whether we are ready to discover them. If they are out there, hidden in the vastness of space, then the greatest adventure in human history is still ahead of us, the search for the strangest and most important stars in the universe. And if we find them, we may finally understand what the cosmos has been trying to tell us all along. The possibility of exotic stars forces us to rethink not just what we know about the universe, but how we even approach the search for truth itself. If such objects exist, they might require us to abandon some of our most deeply held assumptions about physics, space, and even the nature of observation. We have built our understanding of the cosmos on the assumption that all matter behaves in a relatively predictable way, that it interacts with light, gravity, and the fundamental forces in ways we can measure. But exotic matter might not play by those rules. It could be hiding in ways that make it nearly impossible to detect with conventional telescopes, gravitational lensing techniques, or even particle physics experiments. This raises a profound question. If something is real but fundamentally undetectable with our current tools, does it truly exist in any meaningful way? This is the same kind of paradox that has haunted physics since the early days of quantum mechanics. Particles can exist in multiple states at once. The act of observation itself can change reality. Information can seemingly travel faster than light. And now, we face the possibility that some of the most massive, dense, and influential objects in the cosmos might be invisible to us simply because they exist outside the range of our perception. Could entire clusters of exotic stars be hidden in the universe, forming structures that we cannot yet see but which subtly affect the way galaxies move and evolve? One of the most compelling clues that exotic stars could exist comes from the mystery of dark matter. We know that galaxies rotate in a way that defies explanation if we assume they are made only of ordinary matter. The outer edges of galaxies spin much faster than they should, suggesting that there is an unseen mass holding them together. Many theories suggest that dark matter is made of unknown particles, possibly weakly interacting massive particles, WIMPs, or axions. But what if dark matter isn't just a diffuse cloud of particles? What if some of it has coalesced into dense, star-like objects, exotic stars made of dark matter itself? If such stars exist, they would be among the oldest objects in the universe. They could have formed shortly after the Big Bang, when the first structures in the cosmos were coming into being. Unlike ordinary stars, which shine by fusing hydrogen into helium, dark matter stars would operate on entirely different principles. They might generate heat and pressure through interactions we don't yet understand, or they might not emit any light at all, existing as cold, dead masses that nevertheless influence the cosmos through their gravity. Some scientists have even speculated that such objects could be responsible for mysterious cosmic phenomena we have observed but cannot explain, like the unusual distribution of mass in galaxy clusters or the unexplained gravitational waves detected by LIGO. But let's take it a step further. If dark matter stars exist, could they have planets? Could they be surrounded by worlds made of exotic matter, where the laws of physics work in ways we can't even imagine? If so, then the possibility of life in the universe takes on an entirely new dimension. We often assume that life must be based on the same chemistry as Earth's, carbon-based molecules, liquid water, an atmosphere with the right balance of gases. But if exotic matter behaves differently, could there be life forms that exist in an entirely different way, perhaps as energy-based entities or as organisms that experience time in a nonlinear fashion? If such life exists, it would be almost impossible for us to detect or even comprehend. It could be that exotic matter civilizations have been thriving in the universe for billions of years, completely invisible to us because we have been looking in the wrong way. The implications of this idea are staggering. If intelligent civilizations exist within exotic star systems, their entire reality would be different from ours. Their understanding of physics, time, and consciousness might be so far beyond our own that we would be unable to communicate with them. If they have developed advanced technology, it might not resemble anything we recognize: no radio signals, no visible spacecraft, no signs that we would interpret as evidence of intelligence. Instead, their technology might operate on a level that affects the fundamental structure of space-time itself. Could the unexplained anomalies we see in the universe, strange gravitational waves, unexplained energy bursts, even the distortions in the cosmic microwave background, actually be the result of advanced civilizations manipulating exotic matter? If so, then the search for extraterrestrial intelligence needs to be radically rethought. We might not be looking for alien signals in the form of radio waves but rather in the form of gravitational disturbances, fluctuations in the vacuum energy of space, or even shifts in the fundamental constants of nature. If an advanced civilization has learned to manipulate exotic matter, it might have abilities that control over black holes, the ability to create artificial wormholes, even the power to alter the very nature of reality. And what if we are not just observers in this process but part of it? If exotic matter exists and plays a fundamental role in the universe, could it also be a part of us? Some physicists have speculated that dark matter might not be entirely separate from ordinary matter. There could be interactions happening at a level we don't yet understand, perhaps even at the quantum level. What if some of the particles that make up our own bodies have a hidden connection to exotic matter? What if consciousness itself is somehow linked to these hidden forces? This might sound like science fiction, but consider this: we still don't fully understand what consciousness is. Despite decades of research, we have no definitive explanation for how the brain generates self-awareness, thoughts, or emotions. Some scientists believe that consciousness emerges from complex computations in the brain, while others suggest it might be a fundamental property of the universe itself. If the latter is true, could it be that exotic matter plays a role in this process? Could there be a hidden layer of reality, one that we are only dimly aware of, that connects all conscious beings through exotic physics? If so, then the discovery of exotic stars wouldn't just change our understanding of astrophysics. It would change everything. It would force us to question what it means to be alive, to be conscious, to exist. It would challenge our deepest assumptions about reality and force us to confront the possibility that the universe is far stranger than we ever imagined. But here's the most exciting part: we might be on the verge of discovering the truth. With the next generation of telescopes, gravitational wave detectors, and dark matter experiments, we are getting closer than ever to unlocking the secrets of exotic matter. In the next few decades, we may find direct evidence that these mysterious objects exist. And if we do, it will mark the beginning of a new era in science, one where the boundaries between physics, philosophy, and even consciousness itself begin to blur. The universe is not just a collection of stars and galaxies. It is a vast, intricate puzzle, filled with secrets that we are only just beginning to uncover. Exotic stars could be one of the missing pieces, a clue that leads us to an entirely new understanding of existence. And if they are out there, waiting for us to find them, then the greatest discoveries in human history are still ahead of us. The search for exotic stars is not just a question of curiosity. It is a question of redefining what we believe is possible in the universe. If these objects exist, they could change the very foundation of astrophysics, cosmology, and even quantum mechanics. The reason for this is simple. Our current models of the universe are built on the assumption that all matter falls into a few known categories: ordinary matter made of atoms, dark matter that interacts primarily through gravity, and dark energy that drives the universe's expansion. But exotic stars suggest that there may be entire classes of matter that we have never even considered. They would represent an entirely new form of existence, something that sits outside the rules we've painstakingly mapped out over centuries of scientific discovery. If exotic stars exist, the question then becomes, how would we find them? The problem is that they may not interact with light in any detectable way. Unlike normal stars, which shine because of nuclear fusion, exotic stars might not emit light at all. They could be entirely invisible, detectable only through their gravitational influence on their surroundings. This makes them even harder to find than dark matter itself, which is already one of the biggest mysteries in modern physics. However, there might be ways to detect their presence indirectly. One possibility is through gravitational lensing, a phenomenon where a massive object bends the light of distant stars and galaxies behind it. If an exotic star passes in front of a background star, we might see an unexplained magnification or distortion of light that doesn't match the expected properties of normal stars or black holes. Another possibility is through gravitational wave detectors like LIGO and Virgo, which have already detected ripples in spacetime caused by merging black holes and neutron stars. If exotic stars collide, they might produce a gravitational wave signature unlike anything we've seen before. But what if exotic stars don't just exist in isolation? What if they form entire galaxies? If large numbers of exotic stars exist, they might clump together due to gravity, forming structures that resemble ordinary galaxies but behave in strange ways. Such galaxies might appear to contain more mass than they should, or they might rotate differently than expected. They might even be hiding in plain sight, misidentified as irregular galaxies with unexplained properties. Some researchers have already proposed that some of the unexplained mass in galaxy clusters could be due to unknown forms of matter, potentially including exotic stars. The idea of entire galaxies made of exotic matter raises an even bigger question. What if the universe is far more diverse than we ever imagined? We tend to think of the cosmos as being made up of familiar ingredients: stars, planets, black holes, and gas clouds. But what if our observable universe is just one small fraction of a much larger reality, where different types of matter dominate in different regions? What if some parts of the universe are made entirely of exotic matter, operating under physical laws that are completely different from our own? This idea is not as far-fetched as it might seem. Some versions of string theory suggest that different regions of the universe could have different fundamental constants, different values for things like the strength of gravity, the charge of the electron, or even the speed of light. If this is true, then exotic stars might not just be rare anomalies in our universe. They could be the dominant form of matter in other parts of the cosmos. There could be entire realms of existence that are completely separate from the one we know, populated by stars, planets, and possibly even life forms that are built from exotic physics. And if these realms exist, could we ever reach them? This is where things get even more speculative. If exotic matter follows different physical laws, it might be possible to use it to create shortcuts through space, wormholes, or even entirely new dimensions of travel that bypass the limitations of normal physics. Some scientists have proposed that exotic matter could be the key to stabilizing wormholes, allowing for faster-than-light travel, or even connections between different universes. If this is the case, then the discovery of exotic stars wouldn't just change our understanding of the universe. It could change the way we explore it. The implications are staggering. If exotic stars exist, they might hold the key to some of the greatest mysteries in physics: dark matter, dark energy, the nature of space-time, and even the fundamental structure of reality itself. They could be the missing link that explains why the universe behaves the way it does, why galaxies form in the patterns we observe, and why certain cosmic phenomena remain unexplained. But perhaps the biggest mystery of all is whether we are alone in understanding this. If exotic stars exist, could there be civilizations out there that already know about them? If intelligent beings evolved in a region of the universe where exotic matter is common, their entire understanding of physics might be completely different from ours. They might have technology based on principles we cannot even begin to comprehend. They might have the ability to manipulate exotic matter in ways that seem like magic to us, creating energy from nothing, bending space-time, or even traveling between dimensions. And if such civilizations exist, could they be trying to communicate with us? We assume that extraterrestrial intelligence would use radio waves or lasers to send signals. But what if they are using an entirely different medium? Something based on exotic physics that we have not yet discovered. What if the universe is filled with messages, encoded not in electromagnetic radiation but in the fundamental structure of spacetime itself. This brings us to a truly mind-bending possibility. What if we have already encountered evidence of exotic civilizations but didn't recognize it for what it was? Could some of the unexplained signals we've detected, fast radio bursts, strange gravitational waves, or anomalies in the cosmic microwave background, actually be signs of advanced beings manipulating exotic matter? Could some of the unexplained cosmic structures we see be the result of artificial engineering on a scale beyond our imagination? The search for exotic stars is not just about finding new kinds of matter. It is about pushing the boundaries of what we believe is possible. It is about asking whether our understanding of reality is complete, or whether we are missing something fundamental, something that could change everything we think we know. The universe has always surprised us, and history has shown that every time we think we have it all figured out, we discover something that forces us to rethink everything. If exotic stars exist, they could be the next great paradigm shift in science. They could be the key to unlocking a universe far stranger and more complex than we ever imagined. And the most exciting part? We might be closer than ever to finding them. The next few decades of astrophysical research could reveal discoveries that challenge everything we believe about the cosmos. We are standing on the edge of a new frontier, one that could lead us to answers we never even thought to ask. And so, we continue to search. We look to the skies not just for the familiar glow of distant stars, but for something more, for the unseen, the hidden, the exotic. Because if these stars are out there, waiting to be discovered, then the universe is not just more mysterious than we imagined. It is more mysterious than we can imagine. The idea that entire stars could be composed of exotic matter pushes the boundaries of what we consider possible in astrophysics. If such objects exist, they might hold the key to understanding some of the universe's greatest mysteries, including the true nature of dark matter, the limits of fundamental physics, and even the possibility of hidden dimensions. But to truly grasp the significance of exotic stars, we have to dive deeper into the physics that governs them, exploring their potential origins, behaviors, and the far-reaching consequences of their existence. One of the most intriguing possibilities is that exotic stars could have formed in the early universe, during the chaotic moments following the Big Bang. In this scenario, the immense energies present at the dawn of time could have created conditions where exotic matter, strange quark matter, dark matter, or even hypothetical particles beyond the standard model, became gravitationally bound into dense stellar structures. If this happened, then some of these stars might still be out there, lurking in the darkness, waiting to be detected. But there's another possibility that's even more mind-blowing. What if exotic stars aren't just relics of the early universe but are being formed even today? If the right conditions exist in the cores of neutron stars, for example, ordinary matter could collapse into an exotic state, triggering the birth of a new kind of star. Some theories suggest that when neutron stars reach a critical density, their interiors could undergo a phase transition, turning into strange quark matter, a form of ultra-dense matter where the usual distinctions between protons and neutrons break down, creating an entirely new state of existence. If this is happening, it could mean that exotic stars are not rare anomalies but an entirely new category of astrophysical object that we simply haven't recognized yet. And if they exist, they might explain some of the strange cosmic signals we've been detecting, bursts of unexplained radio waves, unusual gravitational wave signatures, and even gamma-ray flashes that don't fit our current models of stellar behavior. But the implications go even deeper. If exotic matter is stable under certain conditions, it could mean that entire planetary systems, or even entire galaxies, are built from it. Imagine a world where the fundamental forces we take for granted operate differently, where gravity, electromagnetism, and nuclear forces interact in ways completely foreign to our understanding. Such a world could host entirely different forms of chemistry, leading to life forms that are completely unrecognizable compared to anything on Earth. And this brings us to one of the biggest questions of all. If exotic stars exist, could they be home to intelligent civilizations? Could there be beings that evolved in environments where exotic matter is the norm rather than the exception? If so, their physics, technology, and way of understanding reality might be so different from ours that we wouldn't even recognize them as life. They might use exotic matter in ways we cannot even begin to comprehend, harnessing energies and manipulating the fabric of space-time itself in ways that seem impossible to us. If such civilizations exist, how would we detect them? Traditional SETI efforts rely on searching for electromagnetic signals, radio waves, laser pulses, or other forms of communication that we understand. But what if an advanced civilization communicates using principles entirely outside our knowledge? What if they send messages not through light or sound, but through the very structure of space-time, using exotic matter as a medium for transmission? This raises the possibility that we have already encountered evidence of such civilizations but failed to recognize it. Could some of the unexplained cosmic phenomena we observe be the result of intelligent manipulation? Could the odd behavior of certain neutron stars, the unexplained gravitational anomalies in deep space, or the strange bursts of energy we detect from distant galaxies be the fingerprints of an advanced civilization using exotic physics? The more we explore these questions, the more we realize how much we don't know. The universe has always defied our expectations, and history has shown that every time we think we have reached the limits of knowledge, something new emerges that forces us to rethink everything. The discovery of exotic stars, if it happens, could be one of those moments, a paradigm shift that completely changes our understanding of physics, cosmology, and even our place in the universe. And so, we continue searching. We develop new telescopes, new detectors, and new methods of analyzing the cosmos. We push the limits of what we know, not because we expect easy answers, but because the unknown is where the greatest discoveries lie. If exotic stars exist, they might be the key to unlocking some of the deepest mysteries of existence. And the most exciting part? We might be closer than ever to finding them. If entire stars made of exotic matter exist, their discovery would mark a fundamental turning point in our understanding of the universe. But what exactly would these stars look like? How would they behave? And most importantly, how would we even recognize one if we saw it? These are the questions that drive some of the most ambitious astrophysical research today. One of the strangest possibilities is that exotic stars might not emit light in the same way as normal stars. Traditional stars, like our Sun, shine because of nuclear fusion. Hydrogen atoms collide and fuse into helium, releasing vast amounts of energy. But an exotic star, especially one composed of strange quark matter or dark matter, might not rely on fusion at all. Instead, its energy could come from entirely different physical mechanisms, such as the slow decay of exotic particles or interactions between fundamental forces that we don't yet understand. This means that exotic stars might not be visible using conventional telescopes. They could be hiding in plain sight, blending into the cosmic background, detectable only through their gravitational influence, or their effects on nearby objects. Some scientists have even proposed that certain unexplained gravitational anomalies, like the unusual motions of stars near the center of our galaxy, could be the result of exotic matter hidden within these objects. But what if exotic stars don't just exist as hidden objects in deep space? What if they play a more direct role in shaping the universe? There's a theory that suggests exotic matter could be responsible for some of the most powerful and mysterious cosmic events we've ever observed. Take, for example, fast radio bursts, brief, intense flashes of radio waves that come from seemingly random locations in the universe. Despite extensive research, we still don't know what causes them. Some theories suggest that exotic stars could be the culprit, generating these bursts through interactions between strange quark matter, dark matter, or other unknown forms of exotic physics. Even more astonishing is the idea that exotic stars could be directly linked to black holes. We usually think of black holes as the final stage of massive stars, objects so dense that not even light can escape their gravitational pull. But what if some black holes aren't actually made from collapsing stars, but instead are the remnants of exotic matter? If this is the case, then some of the black holes we've observed might actually be something entirely different, objects with exotic cores that defy our current models of gravity and quantum mechanics. This idea has profound implications. If exotic matter is stable under extreme conditions, it could mean that black holes aren't the simple, one-way cosmic vacuum cleaners we think they are. Instead, they might harbor exotic physics at their cores, potentially even acting as gateways to unknown regions of the universe. Some theories even suggest that these objects could be linked to wormholes or hidden dimensions, making them far stranger than anything we've ever imagined. The more we explore the concept of exotic stars, the more we realize that they could be the missing piece in many astrophysical puzzles. They might explain the unusual distribution of dark matter, the strange behaviors of neutron stars, and even some of the anomalies in cosmic background radiation. If exotic stars exist, they could be scattered throughout the universe, silently influencing its structure in ways we have yet to comprehend. But how would we go about proving their existence? Scientists are already looking for indirect evidence: gravitational waves that don't match known neutron star or black hole collisions, unexplained bursts of high-energy particles, and inconsistencies in the cosmic microwave background that might hint at exotic interactions. Advanced observatories, such as the James Webb Space Telescope and next-generation gravitational wave detectors, could provide the key to unlocking this mystery. If we do find an exotic star, it would force us to reconsider everything we know about matter itself. The Standard Model of Particle Physics, which describes the fundamental building blocks of the universe, has stood the test of time remarkably well. But exotic stars might be evidence that something even deeper is at play, something beyond the Standard Model, something that could rewrite the laws of physics as we know them. The implications don't stop there. If exotic stars exist, and if they're stable, then in theory it might be possible to create artificial structures using exotic matter. Imagine a civilization advanced enough to harness this physics, building megastructures powered by exotic energy sources, bending space-time at will, or even constructing artificial exotic stars to serve as cosmic beacons. This might sound like pure science fiction, but history has shown that what seems impossible today can become reality tomorrow. The search for exotic stars is ultimately a search for the unknown. It's about challenging our assumptions, pushing the boundaries of what we think is possible, and exploring the deepest mysteries of the cosmos. Whether or not we find them, the journey itself is valuable, because in trying to answer these questions, we might just discover something even more extraordinary along the way. If exotic stars exist, they might be the most elusive objects in the universe, hiding beyond the reach of our current scientific tools. But what if we have already encountered them without realizing it? What if some of the strange cosmic events we've observed, events that defy traditional physics, are actually signals from these mysterious stars? One of the most compelling clues comes from neutron stars. These ultra-dense remnants of supernova explosions already push the limits of our understanding of matter. Scientists believe that deep within their cores, the pressure is so intense that neutrons themselves break down, potentially forming strange quark matter. This leads to the possibility that some neutron stars aren't actually neutron stars at all. They might be something much stranger. If a neutron star collapses further into a quark star, it could transform into an entirely new type of exotic object, with properties radically different from anything we've seen before. A quark star, if it exists, would be made entirely of deconfined quarks, the fundamental building blocks of protons and neutrons. Unlike normal matter, quark matter would behave in bizarre ways. It could be nearly indestructible, resistant to collapse under pressures that would obliterate ordinary stars. If a quark star collided with a normal neutron star, the result could be an explosion unlike anything we've ever detected, perhaps explaining some of the mysterious gamma-ray bursts observed across the cosmos. But quark stars might only be the beginning. Theoretical physics suggests even more exotic possibilities, including electroweak stars, where the weak nuclear force, normally confined to atomic interactions, becomes the dominant mechanism powering the star. These objects could generate energy in ways that defy traditional astrophysics, producing unusual neutrino emissions or gravitational waves that don't match any known celestial events. There's also the possibility of strange matter stars, objects composed entirely of strange quarks, which are heavier and more stable under certain conditions than their up and down quark counterparts. If strange matter is truly stable, it could act as a kind of cosmic virus, spreading its properties to anything it touches. This means that if a strange matter star collided with a normal neutron star, it could transform the entire star into strange matter, fundamentally altering its structure and behavior. The idea of strange matter spreading like an infection across the universe is both fascinating and terrifying. If strange stars exist, then the very fabric of the universe might be more unpredictable than we ever imagined. Could a single strange star seed the growth of an entire cluster of exotic objects, slowly reshaping the structure of galaxies over billions of years? Could some of the unexplained cosmic anomalies we've observed be the result of this transformation process happening on a scale too vast for us to comprehend? And then there's dark matter, one of the greatest unsolved mysteries in cosmology. We know that dark matter makes up most of the mass in the universe, yet we still don't know what it is. Some theories propose that dark matter could form entire stars, which would be invisible to traditional telescopes but detectable through their gravitational influence. If dark matter stars exist, they could be scattered throughout the cosmos, completely unseen, shaping the evolution of galaxies without ever emitting a single photon. But what if some dark matter stars do interact with normal matter in rare and unusual ways? Could some of the unexplained bursts of high-energy radiation we've detected be the result of dark matter stars colliding or decaying? Could some of the strange, pulsar-like signals we've observed be coming from objects that aren't pulsars at all, but rather dark matter stars flickering in and out of detectability? If we ever managed to confirm the existence of an exotic star, the implications would be staggering. It would mean that the universe is far more diverse than we ever imagined, containing states of matter and energy beyond anything we previously thought possible. It could mean that entire regions of space operate under different physical laws, where exotic matter dominates and the normal rules of astrophysics no longer apply. And this brings us to one of the most exciting possibilities of all. If exotic stars exist, could they be harnessed as energy sources by advanced civilizations? If there are alien beings capable of manipulating exotic matter, they might be using these stars in ways we cannot even begin to comprehend. They might be drawing energy directly from their unusual physics, bending the laws of thermodynamics to power their technologies. They might even be using exotic stars as beacons, sending out signals that we have yet to interpret. If this is the case, then we need to rethink our entire approach to the search for extraterrestrial intelligence. Instead of looking for radio signals or laser pulses, we might need to search for strange gravitational anomalies, unexplained bursts of exotic radiation, or other astrophysical signatures that don't fit into our existing models. The search for exotic stars is more than just an academic pursuit. It is a quest to understand the very nature of the universe. It forces us to confront the limits of our knowledge, to question what we think we know about physics, and to imagine possibilities beyond our wildest dreams. If these stars are out there, they are waiting for us to find them. And when we do, the universe will never look the same again. If exotic stars exist, then they represent an entirely new category of celestial objects, ones that defy our traditional understanding of stellar evolution. Normally, stars form from clouds of hydrogen gas that collapse under gravity, eventually igniting nuclear fusion in their cores. But what if, instead of hydrogen, some stars formed from entirely different substances we barely understand, like dark matter, quark matter, or even hypothetical particles that haven't yet been discovered? This idea challenges everything we think we know about how the universe works. It suggests that there might be a hidden side of reality operating beyond our ability to detect, shaping the cosmos in ways we can barely begin to imagine. One of the most intriguing possibilities is that some stars could be made primarily of dark matter. Dark matter is one of the greatest unsolved mysteries in physics. It makes up most of the mass in the universe, yet it doesn't emit, absorb, or reflect light in any way we can directly observe. We only know it exists because of its gravitational influence on galaxies and galaxy clusters. But what if dark matter doesn't just exist in a diffuse form? What if, under the right conditions, it can clump together and form massive, self-sustaining structures, dark stars? Theoretical models suggest that if dark matter particles interact with each other in just the right way, they could accumulate in high-density regions and form objects that mimic the gravitational effects of traditional stars. Unlike normal stars, which shine by converting hydrogen into helium through nuclear fusion, dark stars would generate energy through an entirely different process, self-annihilation of dark matter particles. If dark matter is made of weakly interacting massive particles, WIMPs, then under the immense pressure of a star-like structure, these particles could collide and annihilate each other, releasing bursts of energy in the process. This could produce heat and light, but in wavelengths that might be difficult for our current telescopes to detect. If dark stars exist, they could be scattered throughout the cosmos, hiding in plain sight. Some scientists have speculated that they might be responsible for some of the unexplained excesses of infrared radiation detected in certain parts of the sky. Others believe that they could be masquerading as unusually dim or cool stars, blending in with their ordinary counterparts while obeying entirely different physical laws. Some even propose that the first generation of stars in the universe, the so-called population 3 stars, could have included dark matter stars, which might have played a role in shaping the formation of galaxies. But dark stars are only one possibility. There could be even more exotic forms of matter hidden in the universe, waiting to be discovered. One such possibility is the existence of electroweak stars, hypothetical objects where the weak nuclear force, normally confined to atomic interactions, dominates the star's behavior. In an electroweak star, matter wouldn't be converted into energy through nuclear fusion, but rather through the interactions of fundamental particles at an incredibly small scale. Theoretically, these stars could last far longer than normal stars, burning in a steady state for trillions of years, potentially outlasting the lifespan of the universe itself. Another possibility is the existence of quark stars, which could be even more extreme than neutron stars. In a neutron star, gravity compresses matter to the point where atoms can no longer exist separately, and their protons and electrons merge into neutrons. But if the pressure continues to rise, neutrons themselves could break down into their constituent quarks, forming an entirely new type of matter, quark-gluon plasma. This state of matter is believed to have existed in the earliest moments of the universe, just microseconds after the Big Bang, when temperatures and pressures were unimaginably high. A quark star would be unlike anything we've ever observed. It would be incredibly small, perhaps only a few kilometers in diameter, but it would contain more mass than the Sun. Its surface might be covered in a thin crust of normal matter, but beneath that, the interior would be a swirling ocean of free quarks, held together by the immense force of gravity. Some models suggest that quark stars might have unique magnetic properties, or that they could emit strange bursts of radiation that don't match the patterns of normal neutron stars. But there's an even more radical idea, strange stars, which would be made entirely of strange matter. Strange matter is a theoretical form of matter that contains not just up and down quarks, which make up normal protons and neutrons, but also strange quarks. Some physicists believe that strange matter might be more stable than ordinary matter under extreme conditions, meaning that if it ever formed naturally, it might persist indefinitely. If strange stars exist, they could be incredibly dangerous. Theorists have suggested that if strange matter comes into contact with normal matter, it could convert it into more strange matter, spreading like a virus. If this were true, then even a small amount of strange matter colliding with a neutron star could trigger a chain reaction, transforming the entire star into a strange star in a matter of moments. Some have even speculated that this process could explain certain unexplained cosmic explosions, events where neutron stars seem to vanish or behave in unexpected ways. But perhaps the most mind-bending possibility is that there are forms of exotic matter we haven't even theorized yet. The laws of physics, as we currently understand them, are based on experiments conducted here on Earth and observations of relatively normal astronomical objects. But the universe is vast, and it may contain entire categories of matter and energy that we haven't yet encountered. Could there be stars made of entirely unknown particles? Could there be objects that exist in a state beyond anything we can currently describe, stars that don't emit light in any conventional sense, or that operate under physical principles we haven't yet discovered? Some physicists believe that if extra dimensions exist, as proposed by certain string theory models, then there could be stars that exist partially in higher dimensional space. These objects might have gravitational effects we can detect, but their true nature would remain hidden from us, existing outside the three-dimensional universe we perceive. If exotic stars exist, then finding them would revolutionize our understanding of astrophysics, particle physics, and the fundamental nature of reality. It would mean that the periodic table of elements we rely on is only a tiny fragment of what's possible. It would mean that the types of stars we've categorized, main sequence stars, white dwarfs, neutron stars, and black holes, are just a fraction of the celestial objects that actually populate the cosmos. And perhaps most intriguingly, it would mean that the search for life in the universe might need to be reconsidered entirely. If exotic matter exists, then who's to say that life itself couldn't take on exotic forms? What if intelligence can arise in ways that don't rely on carbon, water, or even molecules as we know them? What if there are civilizations out there built around strange matter, dark matter, or entirely unknown substances? What if the signals we've been searching for, radio waves, electromagnetic pulses, and other familiar forms of communication, are irrelevant to these beings, who may operate on physical principles completely different from our own? The implications are staggering. Exotic stars could be a missing piece of the cosmic puzzle, linking together dark matter, the fundamental forces of nature, and the origins of the universe itself. And if they are out there, then with each new astronomical observation, each new breakthrough in physics, we are getting closer to discovering them. The question is, when we finally find them, will we be ready to understand what we're looking at? The search for exotic stars isn't just a theoretical exercise, it's an open challenge in modern astrophysics. Every time we build a more powerful telescope or develop new methods of detecting the unseen, we inch closer to answering this profound mystery. The question isn't just whether these stars exist, it's whether we've already observed them without realizing it. Some astrophysicists suspect that anomalies in the data we've collected from distant stars, pulsars, and other cosmic objects might already hint at the presence of exotic matter. The problem is that without definitive proof, we can't be sure what we're looking at. Consider the enigmatic neutron stars known as magnetars. These incredibly dense remnants of supernova explosions possess magnetic fields a quadrillion times stronger than Earth's. They behave in ways that challenge our understanding of stellar physics. Some magnetars emit bursts of gamma rays and X-rays so intense that they could strip the atmosphere from a planet from thousands of light-years away. Others have exhibited unusual rotational slowdowns or speed-ups that defy expectations. Could some of these objects be more than just neutron stars? Could they actually be strange stars or quark stars in disguise? If even one of these extreme objects were found to contain exotic matter, it would force us to rewrite textbooks on stellar evolution. But what if there are stars that don't fit into any known category? What if there are objects that don't emit light the way we expect, or that only become visible under specific cosmic conditions? Some researchers have suggested that exotic stars might emit neutrinos or gravitational waves rather than traditional electromagnetic radiation. If so, they could be hiding in plain sight, invisible to our conventional telescopes but detectable through future experiments in neutrino physics or gravitational wave astronomy. The Laser Interferometer Gravitational Wave Observatory, LIGO, and the Virgo detector have already changed the way we study the universe, capturing ripples in spacetime caused by colliding black holes and neutron stars. But what if one of these signals someday reveals something even stranger? An object that doesn't match the expected signature of a neutron star or black hole, but instead suggests the presence of an entirely new form of matter. If that happens, it won't just be a breakthrough in astronomy, it will be one of the most important discoveries in the history of science. One of the most fascinating aspects of this mystery is the role that exotic matter might play in the fate of the universe itself. If dark matter, strange matter, or other unknown substances can form stable stars, then they could influence cosmic evolution in ways we've never considered. Perhaps some galaxies are dominated by exotic stars, making them appear dimmer or more diffuse than expected. Perhaps entire regions of space are filled with objects that defy our current understanding of physics, affecting the structure and dynamics of the universe on the largest scales. And what about black holes? Could some black holes actually be exotic stars that have reached the ultimate limit of stability? Some physicists have speculated that certain black holes might not be singularities at all, but instead ultra-dense objects made of exotic matter, held together by forces we don't yet understand. If that's true, then some of what we think are black holes might actually be something even stranger, objects that bend the laws of physics but don't collapse into true singularities. The implications of discovering exotic stars go far beyond astronomy. If we find that exotic matter can form stable structures, then it could revolutionize particle physics. It might provide clues about the unification of fundamental forces, the nature of dark matter, and even the potential existence of new dimensions beyond the three spatial dimensions we experience. In other words, understanding these stars might be the key to answering some of the biggest questions in all of physics. Questions about the true nature of the universe and our place within it. But perhaps the most mind-blowing possibility is that exotic matter could be the foundation for something even more remarkable: life itself. If exotic stars exist, then what about exotic planets? Could entire planetary systems form around these stars, governed by unfamiliar laws of physics? And if so, could life emerge in these environments, adapted to conditions unlike anything we've ever imagined? For years, scientists have speculated about the possibility of life based on alternative chemistries. Life that doesn't rely on carbon, water, or even DNA as we know it. But if exotic matter exists, then the range of possibilities expands even further. Could there be beings composed of dark matter, interacting through forces we can't yet detect? Could there be civilizations built around quark-based or strange matter ecosystems, living in environments where our form of life would be impossible? And if such life exists, would we even be capable of perceiving it? The search for extraterrestrial intelligence has long been focused on detecting radio signals, searching for patterns in electromagnetic waves that suggest intelligent origins. But what if the civilizations we seek don't communicate using electromagnetic waves at all? What if they transmit signals through exotic particles, or through gravitational waves, or even through mechanisms beyond our current understanding? If that's the case, then we may have been looking in the wrong places all along. Some theorists have suggested that if dark matter civilizations exist, they could be completely undetectable by our technology. They might occupy the same regions of space as we do, but exist in a form that is effectively invisible to us. Some have even speculated that dark matter itself might be evidence of a hidden network of structures, perhaps even artificial ones, spread throughout the cosmos. Could it be possible that dark matter is not just a fundamental component of the universe, but the byproduct of some ancient, advanced technology? The idea sounds like science fiction, but so did black holes, dark matter, and quantum mechanics before they were accepted as real phenomena. If we've learned anything from history, it's that the universe is always stranger than we expect. The deeper we look, the more mysteries we uncover. Exotic stars may be one of the greatest mysteries of all, not just because they challenge our understanding of astrophysics, but because they hint at a reality far beyond anything we currently comprehend. If these stars exist, then finding them will be one of the greatest scientific achievements of all time. It will reshape our understanding of the cosmos, redefine the boundaries of physics, and perhaps even reveal the existence of forms of life we never imagined possible. The search is only beginning, but one thing is certain: when we finally discover the truth about exotic matter, it will change everything. The deeper we dive into the mystery of exotic stars, the more we realize just how much we don't know about the universe. Every time we think we've reached the limits of our understanding, something new emerges, some anomaly in the data, some unexplained cosmic phenomenon that challenges everything we thought we knew. This is the nature of scientific progress. One answer leads to 10 more questions, and the search for exotic matter is no exception. The more we investigate, the more we realize how much remains hidden in the vastness of space. One of the biggest challenges in identifying exotic stars is that we still don't fully understand how ordinary matter behaves under extreme conditions. When we study neutron stars, for example, we're already dealing with matter in a state so extreme that it pushes the limits of our physical theories. A neutron star is so dense that a single sugar cube-sized portion of it would weigh billions of tons on Earth. The pressures inside are beyond anything we can recreate in a laboratory. And yet, even within these extreme conditions, we still don't know exactly what happens at the core. Could some of these neutron stars actually contain exotic matter? Could some of them be strange stars or quark stars, with interiors completely different from what we expect? Some astrophysicists believe that there may be a smooth transition between neutron stars and quark stars, meaning that some objects we classify as neutron stars could actually contain exotic matter deep within their cores. If this is the case, then we may have already observed exotic stars without realizing it. The challenge is finding a way to detect them conclusively. Since we can't directly see inside a neutron star, we have to rely on indirect evidence, things like mass, radius, and cooling rates. If a star behaves in a way that doesn't match what we expect from a neutron star, it could be a sign that something strange is happening inside. One potential clue comes from pulsars, rapidly spinning neutron stars that emit beams of radiation like cosmic lighthouses. Some pulsars have been observed to slow down or change their spin rates in unexpected ways. In some cases, this could be due to interactions with companion stars or magnetic field effects. But in other cases, the cause is completely unknown. Could it be that some of these pulsars are actually exotic stars, with internal structures that behave differently from what we expect? If so, then finding the right pulsar could be the key to proving the existence of exotic matter. Another potential clue comes from neutron star mergers. When two neutron stars collide, they release an enormous burst of energy, sending gravitational waves rippling through space-time. These mergers have been detected by LIGO and Virgo, and they provide a unique opportunity to study the properties of ultra-dense matter. If some neutron stars are actually exotic stars, then their mergers should produce different signals from what we expect. By carefully analyzing the data from these events, scientists might be able to find evidence of strange matter or other exotic states of matter. But what if exotic stars don't look anything like neutron stars at all? What if there's something completely different, objects that we've never even considered? Some theories suggest that there could be entirely new classes of stars made of dark matter, held together by forces beyond the standard model of physics. These stars wouldn't emit light in the same way as ordinary stars, making them incredibly difficult to detect. They might only interact with normal matter through gravity, meaning that they could be drifting through galaxies, completely invisible except for their gravitational influence. If such stars exist, then they could help explain one of the biggest mysteries in astrophysics, the missing mass problem. When we observe galaxies, we find that their visible matter, stars, planets, gas, and dust, doesn't account for all of their gravitational effects. There's extra mass there, something unseen that's holding galaxies together. This is what we call dark matter. Most scientists believe dark matter is made of unknown particles, but what if some of it is actually in the form of dark stars, massive, invisible objects that we've never been able to detect? This idea is speculative, but it's not impossible. If dark matter has any kind of self-interaction, meaning that its particles can stick together under certain conditions, then it's conceivable that dark matter could form stars, planets, or even entire dark galaxies that exist alongside the visible universe. If that's the case, then our view of the cosmos is incomplete. There could be entire structures out there that we simply can't see, influencing the evolution of galaxies and shaping the large-scale structure of the universe without us even realizing it. Some scientists have even proposed that dark stars could have played a role in the early universe. In the first few 100 million years after the Big Bang, before the first normal stars formed, there could have been a period when dark matter collapsed into massive objects. These primordial dark stars wouldn't have emitted normal light, but they could have acted as gravitational beacons, shaping the distribution of matter and influencing the formation of galaxies. If we could find evidence of these objects today, perhaps through their gravitational lensing effects or their impact on cosmic background radiation, it would be one of the most profound discoveries in modern physics. But perhaps the most mind-blowing possibility is that exotic matter isn't just a curiosity of extreme physics. It could be the foundation for new forms of life. If dark stars or strange stars exist, then what about exotic planets? Could entire planetary systems be built around these stars, governed by laws of physics different from what we know? And if so, could life emerge in these environments, adapted to conditions unlike anything we've ever imagined? This idea challenges everything we think we know about habitability. We typically define habitable zones based on the presence of liquid water and temperatures suitable for carbon-based life. But if exotic matter exists, then the rules might be completely different. There could be entire ecosystems based on strange matter, quark-based chemistry, or interactions between dark matter particles. These forms of life wouldn't be detectable using our current methods. They wouldn't emit the same kind of biosignatures we look for in exoplanet studies. If they exist, they might be completely invisible to us, just like dark matter itself. Some scientists have speculated that if dark matter civilizations exist, they could be completely undetectable by our current technology. They might occupy the same regions of space as we do, but exist in a form that is effectively invisible to us. Some have even suggested that dark matter itself might be evidence of a hidden network of structures, perhaps even artificial ones, spread throughout the cosmos. Could it be possible that dark matter is not just a fundamental component of the universe, but the byproduct of some ancient, advanced technology? The search for exotic stars is not just about finding new types of celestial objects, it's about pushing the boundaries of what we know about physics, chemistry, and even the nature of reality itself. If these stars exist, then discovering them will be one of the most important scientific breakthroughs of all time. It will reshape our understanding of the cosmos, redefine the boundaries of physics, and perhaps even reveal the existence of life forms we never imagined possible. And the best part? This search is only just beginning. The next generation of telescopes, gravitational wave detectors, and particle physics experiments could provide the answers we've been looking for. The question isn't just whether exotic stars exist, it's whether we've already seen them without realizing it. The universe is full of secrets, waiting to be uncovered. And when we finally unlock the truth about exotic matter, it could change everything we know about the cosmos. The deeper we go into the possibilities of exotic matter, the more we start to question the very fabric of the universe. Could it be that exotic stars aren't just a rare phenomenon but a fundamental part of reality itself? Could the laws of physics we take for granted only be a subset of a much larger, more complex framework? One that allows for matter and energy to exist in ways we can't even comprehend yet? This isn't just a theoretical exercise. If exotic stars exist, then their discovery could force us to rethink the standard model of physics, our understanding of gravity, and even the way we define what a star really is. At its core, a star is simply an object that generates energy through some internal process. For normal stars, that process is nuclear fusion. For neutron stars, it's the residual heat from gravitational collapse combined with occasional bursts of nuclear reactions. But if we introduce exotic matter into the equation, new possibilities emerge. Some scientists have speculated that strange stars, composed of strange quark matter, could generate heat and energy through entirely different means. Instead of relying on fusion, these stars might be powered by quark interactions, vacuum energy fluctuations, or even processes that involve higher dimensional physics. One of the more radical ideas is that some exotic stars might act as natural particle accelerators, continuously generating exotic particles and antimatter in ways that violate our expectations of conservation laws. If such stars exist, they could provide clues to some of the biggest mysteries in physics, including why our universe is made mostly of matter instead of antimatter. The asymmetry between matter and antimatter is one of the great unsolved problems in cosmology. In theory, the Big Bang should have produced equal amounts of both, leading to a universe where everything annihilates into pure energy. Yet somehow, we ended up with a universe dominated by matter. Could exotic stars hold the answer? Some scientists believe that if exotic stars exist, they might be detectable through their unique emissions. Normal stars produce light through well-understood mechanisms, fusion, blackbody radiation, and interactions with surrounding gas. But exotic stars might emit energy in entirely different ways. They could produce intense bursts of gamma rays, streams of exotic particles, or even gravitational waves that don't match anything we've seen before. This raises an intriguing question. Have we already detected these signals without realizing it? Over the past few decades, astronomers have observed a number of unexplained cosmic phenomena that don't fit neatly into our models. One example is fast radio bursts, FRBs, intense, millisecond-long bursts of radio waves originating from distant galaxies. Some FRBs are one-time events, while others repeat in irregular patterns. The cause of these bursts is still unknown, but some scientists have suggested that they could be the signatures of exotic stars undergoing sudden transitions in their internal states. If a strange star or a quark star suddenly changed its composition, perhaps shifting from one type of exotic matter to another, it could release an enormous amount of energy in the form of a fast radio burst. Then there's the case of ultra-high-energy cosmic rays. These are particles, often protons or atomic nuclei, that strike Earth's atmosphere with energies millions of times higher than what we can achieve in particle accelerators. Their origins are a complete mystery. Some theories suggest they come from supermassive black holes or colliding galaxies, but others propose a more exotic explanation, that they could be emitted by strange stars or other exotic objects. If true, this would mean that some of the most energetic particles in the universe aren't coming from normal astrophysical processes, but from something far more unusual. But what about dark matter stars? If dark matter can form structures, then could it also form entire stars? Some physicists have proposed that there might be an entire class of stars made primarily of dark matter. These stars wouldn't shine like normal stars, since dark matter doesn't interact with light. Instead, they would be detectable only through their gravitational effects. Some models even suggest that dark stars could have formed in the early universe before normal stars, acting as the first massive objects in existence. If dark stars exist, then they could be hiding in plain sight. The Milky Way is thought to be filled with dark matter, forming an invisible halo around the galaxy. Within this halo, there could be dark matter stars drifting undetected, affecting the motion of nearby objects in ways we haven't yet recognized. Some scientists have even speculated that black holes might sometimes form from the collapse of dark matter rather than normal matter, meaning that some of the black holes we've detected through gravitational waves might actually have originated from exotic physics. The implications of exotic stars go far beyond astrophysics. If these objects exist, they could provide direct evidence for new physics beyond the standard model. They could help us understand the fundamental forces that govern the universe and even give us clues about the nature of dark matter, dark energy, and extra dimensions. Some theories suggest that certain types of exotic matter might be linked to hidden dimensions of spacetime, meaning that the study of these stars could lead to the first experimental evidence of higher dimensions. Even more astonishing is the possibility that exotic stars could be artificial. If an advanced civilization had access to exotic matter, they might be able to create stars with entirely new properties. Imagine a civilization capable of engineering a quark star or harnessing the energy of a dark matter star. Such a civilization would have control over forces far beyond anything we can currently comprehend. Some scientists have even speculated that certain unexplained astrophysical phenomena, such as unusually stable pulsars or strange patterns in cosmic radiation, could be signs of artificial megastructures created by advanced beings. If that sounds like science fiction, consider this: we already manipulate matter in ways that would seem impossible to civilizations from the distant past. We split atoms to generate nuclear energy, we create artificial black holes and particle accelerators, and we manipulate quantum states to perform computations. If humanity survives long enough, who's to say we won't eventually learn to create and control exotic matter? The idea that some distant civilization has already achieved this isn't so far-fetched. Ultimately, the search for exotic stars is about more than just finding new types of celestial objects. It's about pushing the boundaries of what's possible. It's about challenging our understanding of the universe and asking questions that go beyond the limits of known physics. Could entire stars be made of exotic matter? Could the universe be filled with objects we've never even considered? Could the very nature of reality be far stranger than we ever imagined? These are the kinds of questions that drive scientific discovery. And as our technology improves, as our telescopes get more powerful and our detectors more sensitive, we may finally start to find the answers. The universe is vast, mysterious, and full of surprises. The only real question is, are we ready to discover them? The more we consider the idea of exotic stars, the more we start to realize that our current understanding of the universe may be just a small fraction of the full picture. What if the standard model of astrophysics, our rules for how stars form, shine, and die, is merely a local rule set that applies only to the ordinary matter we're familiar with? What if, beyond the limits of our detection, entire populations of stars exist that don't follow the same processes we've come to expect? We assume that stars must be made of hydrogen and helium, that they must shine due to nuclear fusion, and that their lives end in predictable ways, either as white dwarfs, neutron stars, or black holes. But the universe doesn't have to conform to our expectations. It has no obligation to be understandable to us. What if our detection methods, our models, and even our ways of thinking are simply too limited to perceive the true diversity of celestial objects that might exist? One of the biggest questions is how we would even begin to detect an exotic star if one existed. Normal stars shine because of the energy they release, whether through fusion or gravitational collapse. But what if an exotic star emits radiation in a way that doesn't conform to these processes? What if it interacts with space-time in a completely different manner? Some theoretical models suggest that certain types of exotic stars could emit mostly gravitational waves instead of light. In that case, they could be hidden in plain sight, massive objects influencing the structure of the universe, but effectively invisible to traditional telescopes. We already know that some cosmic phenomena defy easy explanation. Take ultraluminous X-ray sources, ULXs, for example. These are objects that shine with brightness levels far beyond what we'd expect from ordinary black holes or neutron stars. Some of them seem to exist in environments where no known astrophysical process should be able to generate that much energy. Could ULXs be powered by exotic matter? Could they be signs of stars operating under unknown physics? Then there are cosmic voids, vast regions of space that appear almost completely empty, with very few galaxies, stars, or even dark matter. Some have speculated that if exotic stars exist, they might be clustered in these voids, making them nearly impossible to detect with conventional methods. Another clue could come from rogue planets, planets that drift through space without being bound to any star. We've detected quite a few of these, and they raise an important question: how many other celestial objects might exist outside of traditional star systems? Could there be rogue stars, stars not bound to galaxies, but drifting alone through intergalactic space, powered by exotic matter? If they emit little or no conventional light, we might never have noticed them. But their gravitational influence could still be there, subtly affecting the motion of other objects. Then there's the question of what happens when exotic stars die. If a strange star or a quark star collapses, does it form a black hole like ordinary stars? Or does it leave behind something even stranger? Some physicists have proposed that certain kinds of exotic matter could resist collapse, forming stable remnants that defy our understanding of physics. There's even speculation that some black holes might not be black holes at all, but instead be exotic objects masquerading as black holes, dark, compact remnants of stars made entirely of unknown forms of matter. And what about the early universe? Could exotic stars have been far more common in the distant past? Some models suggest that during the first few moments after the Big Bang, conditions were radically different from what we see today. The universe was hotter, denser, and filled with high-energy particles that no longer exist in large numbers. Could it be that exotic stars were once common but have since faded away, leaving only indirect traces of their existence? If that's the case, then some of the unexplained cosmic radiation we detect today might be the dying echoes of these ancient, long-gone objects. The search for exotic stars isn't just about understanding what's out there. It's about testing the limits of physics itself. Every time we discover something new, whether it's an unexplained cosmic burst, an anomaly in gravitational wave data, or an object that doesn't behave the way it should, we get closer to uncovering the hidden structure of reality. Exotic stars might not just be a curiosity. They could be the key to some of the biggest unanswered questions in science. What is dark matter? What is dark energy? What happens inside a black hole? Are there extra dimensions? If exotic matter exists in the form of entire stars, then studying them could be the first step toward answering these fundamental mysteries. As our technology improves, we'll be able to look deeper into space and detect fainter and more unusual signals. The next generation of telescopes, like the James Webb Space Telescope and the upcoming Extremely Large Telescope, might be able to spot objects that don't fit into any known category. And if we do find an exotic star, it will change everything. It will mean that the laws of physics, as we know them, are incomplete. It will mean that there's a whole new layer of reality waiting to be explored. But perhaps the most exciting possibility is that exotic stars might not be rare at all. Maybe they're everywhere, hiding just beyond the limits of our detection, waiting for us to finally recognize them for what they are. The universe is far stranger than we can imagine, and we've barely scratched the surface of its mysteries. The only real question is, are we ready to face what we might find? The more we push the boundaries of our understanding, the more we realize that exotic stars could be a crucial missing piece in our cosmic puzzle. If entire stars are made of exotic matter, then we must ask, how do they form, how do they evolve, and how do they interact with the rest of the universe? These questions challenge the very foundations of astrophysics, forcing us to reconsider the nature of matter, gravity, and even space-time itself. If exotic stars exist, their presence might explain some of the strangest astronomical phenomena we've observed: unusual X-ray emissions, unexplained gravitational anomalies, and cosmic structures that defy conventional models. One of the most intriguing possibilities is that exotic stars might not follow the same life cycle as ordinary stars. In a traditional star, nuclear fusion provides the energy that counteracts gravity, keeping the star stable. But if a star is made entirely of exotic matter, such as quark matter, strange matter, or even dark matter, then fusion might not be necessary at all. Instead, the star could be powered by entirely different forces, such as quantum effects or interactions with higher dimensional space. This would mean that exotic stars could be incredibly long-lived, possibly existing for billions or even trillions of years without undergoing the same kind of nuclear reactions that power ordinary stars. But what if these stars have already been detected, just not recognized for what they truly are? Some neutron stars exhibit behavior that defies explanation, such as rotating at incredible speeds or emitting bursts of energy that don't fit any known pattern. These could be clues that at least some neutron stars are actually strange stars, composed of exotic matter rather than ordinary neutrons. If this is the case, then our galaxy could be filled with stars that operate under entirely different principles than what we've assumed. Then there's the question of what happens when an exotic star reaches the end of its life. In an ordinary star, the end result is typically a white dwarf, a neutron star, or a black hole. But an exotic star could collapse into something far stranger. Some theories suggest that instead of forming a black hole, an exotic star might form a gravistar, a hypothetical object where quantum effects create a stable core that prevents complete collapse. Others propose that certain exotic stars could leave behind remnants that interact with dark matter in unusual ways, potentially explaining some of the gravitational anomalies we observe in the universe. If exotic stars exist, then they might also play a role in galaxy formation. Dark matter is known to influence the structure of galaxies, but its nature remains a mystery. Could exotic stars be a part of this hidden mass? If entire stars are composed of dark matter, then they would be invisible to conventional telescopes, but their gravitational influence would still shape the cosmos. This could mean that some of the most massive structures in the universe are actually built around exotic stars, rather than ordinary matter. And what if exotic stars have already left their mark on the early universe? The cosmic microwave background radiation, the faint glow left over from the Big Bang, contains subtle fluctuations that scientists are still trying to fully explain. Some of these fluctuations could be the result of exotic stars forming and interacting in ways we don't yet understand. If we can find evidence of their existence in the cosmic background radiation, it would be one of the greatest discoveries in the history of physics. As our observational tools improve, we may finally be able to answer some of these questions. The upcoming generation of space telescopes and gravitational wave detectors will allow us to probe deeper into the universe than ever before. If exotic stars are out there, these instruments might be able to detect their unique signatures, perhaps in the form of unusual gravitational waves, unexplained bursts of energy, or even entirely new types of radiation. But the most exciting possibility is that exotic stars might not be rare. They might be a fundamental part of the universe, hidden in plain sight, waiting for us to recognize them. If we can unlock their secrets, we may finally begin to understand the true nature of matter, energy, and the cosmos itself. If exotic stars are real, then the implications stretch far beyond astrophysics. They touch on the very nature of reality itself. The universe is filled with unexplained phenomena, from dark matter halos surrounding galaxies to mysterious fast radio bursts originating from the depths of space. If entire stars are composed of exotic matter, then they could hold the key to solving these cosmic puzzles. But what makes these hypothetical stars so different from the ones we know? To understand this, we need to look at the properties of exotic matter itself. One of the most discussed possibilities is strange matter, which consists of up, down, and strange quarks. In theory, strange matter is incredibly stable and could persist under extreme conditions where normal matter would collapse. If a star were made of strange matter, it wouldn't need to rely on nuclear fusion to maintain its structure. Instead, the fundamental properties of quark interactions would create enough pressure to counteract gravity, forming a stable, long-lived object. These strange stars could appear similar to neutron stars but with key differences, perhaps being denser, smaller, or even emitting radiation in unusual ways. Another possibility is that exotic stars could be composed of dark matter. Dark matter makes up roughly 85% of the universe's mass, yet we still don't know what it is. If some regions of space contain enough dark matter to collapse under gravity, it could theoretically form entire stars. But unlike normal stars, dark matter stars wouldn't shine in the way we expect. They might only be detectable through their gravitational influence, or by emitting exotic particles that don't interact with light. This could explain some of the strange gravitational anomalies we've observed, such as galaxies that seem to rotate in ways that defy our models. One of the most fascinating aspects of exotic stars is the possibility that they might have already been observed, but misidentified. Some astrophysical objects don't fit neatly into existing categories. Take magnetars, for example, extremely magnetic neutron stars that release bursts of high-energy radiation. Could some magnetars actually be exotic stars, emitting energy due to unknown interactions rather than the usual neutron star mechanisms? Or what about the recently discovered odd radio circles in space, huge, mysterious rings of radio waves with no obvious source? If exotic stars are involved, they could be producing strange energy signatures that we simply don't recognize yet. Even more intriguing is the idea that exotic stars could be remnants of the early universe. If unusual forms of matter were more common in the first moments after the Big Bang, then some of these objects might have survived to the present day. This would mean that exotic stars could be relics of an era when the laws of physics were different, holding clues to the fundamental forces that shaped everything we see today. If we could find one of these primordial objects, it might help us unlock mysteries about the origins of the universe itself. But how would we go about detecting something so strange? Traditional telescopes rely on light, but exotic stars might not emit light in the same way normal stars do. Instead, we might need to look for their gravitational effects. Advanced gravitational wave detectors, like LIGO and Virgo, are already picking up signals from black hole and neutron star collisions. If exotic stars exist, then their mergers might produce unique gravitational wave patterns, revealing their presence. Similarly, upcoming space telescopes could detect exotic radiation or high-energy particles that don't match any known sources. Perhaps the most unsettling thought is that exotic stars might be hiding right in our own cosmic backyard. If some stars in our galaxy are made of exotic matter, then our models of stellar evolution would need to be rewritten. What if an exotic star is lurking in a neighboring star system, waiting for us to recognize it? What if some of the objects we've labeled as neutron stars or white dwarfs are actually something far stranger? The possibility is both thrilling and humbling. It suggests that despite all we've learned about the universe, we may still be missing something fundamental. And then there's the ultimate question: what happens when an exotic star dies? If exotic matter resists collapse, then some of these stars might persist indefinitely, never forming black holes in the traditional sense. Or they might collapse into something even stranger, objects that defy even our most advanced theories of physics. Some scientists have speculated about Planck stars, hypothetical remnants of collapsed objects that are stabilized by quantum effects at the smallest scales. If exotic stars produce such remnants, they could be gateways to entirely new physics, showing us the limits of what we think is possible. As we continue to explore the cosmos, the discovery of an exotic star would be one of the most profound breakthroughs in modern science. It would mean that the building blocks of reality are more varied and complex than we ever imagined. It would challenge everything we assume about how stars form, evolve, and die. And most importantly, it would remind us that the universe is far stranger than we ever dared to believe. If exotic stars exist, they could be the missing link in some of the biggest mysteries in astrophysics. Their existence would reshape our understanding of matter, gravity, and even the fundamental forces that govern the universe. But what if the implications go even further? What if exotic stars don't just exist as strange outliers, but instead, they play a crucial role in shaping the cosmos in ways we haven't yet realized? Consider the possibility that exotic stars might not be formed through the same processes as ordinary stars. In a traditional stellar evolution model, stars form when vast clouds of gas collapse under their own gravity, eventually igniting nuclear fusion. But what if exotic stars don't require this process at all? What if they simply coalesce directly from exotic forms of matter that existed since the early universe? If this were the case, then exotic stars might not just be rare anomalies. They could be remnants of the first moments after the Big Bang, forming in a completely different way than normal stars. This raises another intriguing question: could entire galaxies or star clusters be composed primarily of exotic stars? If that's the case, then our models of the universe's large-scale structure would need to be rethought. Imagine a hidden population of exotic stars scattered throughout the cosmos, invisible to traditional telescopes but influencing their surroundings through gravity. This could be one reason why we observe discrepancies in galaxy rotation curves, which are often attributed to dark matter. If a portion of this unseen mass consists of exotic stars, then it might mean that these objects are much more common than we ever suspected. And what about the role of exotic stars in black hole formation? In standard physics, when a massive star collapses, it can either form a neutron star or a black hole, depending on its mass. But if a star is made of exotic matter, this process could behave very differently. Some exotic stars might never collapse into black holes at all, instead remaining stable due to the unique properties of their matter. Others might undergo an entirely different kind of collapse, forming objects that don't fit into any known category, perhaps even leading to the creation of entirely new states of matter that we've never observed. There's also the possibility that exotic stars could interact with dark energy, the mysterious force driving the accelerated expansion of the universe. If exotic matter interacts with spacetime in a different way than ordinary matter, then these stars could have effects on cosmic expansion that we haven't yet accounted for. Some scientists have speculated that dark energy might not be a uniform force, but rather the result of interactions between exotic particles that we haven't detected yet. If exotic stars contribute to this process, then they could be directly influencing the fate of the universe itself. And let's not forget about the possibility of entirely new physics emerging from these objects. If exotic stars contain matter that doesn't obey the standard model of particle physics, then studying them could reveal hidden aspects of the universe's fundamental forces. They might be powered by unknown interactions, creating conditions that we've never been able to replicate in a laboratory. This could lead to the discovery of entirely new particles, forces, or even dimensions that we've never considered before. If we ever manage to locate and study an exotic star up close, the insights gained could revolutionize our understanding of physics, astronomy, and cosmology. Imagine a future where advanced telescopes or space probes detect an exotic star and allow us to analyze its properties in detail. The data gathered could challenge our existing theories, forcing us to rethink not just how stars work, but how the entire universe functions. But perhaps the most exciting aspect of all is that we might not be far from making such a discovery. With the next generation of space telescopes, gravitational wave detectors, and high-energy particle observatories, we are entering an era where the search for exotic stars is more feasible than ever. If these objects are out there, it may only be a matter of time before we find them, and when we do, the universe may never look the same again. If exotic stars exist, then we have to consider the mind-bending possibility that the very foundation of astrophysics might need to be rewritten. These aren't just hypothetical oddities. If they are real, they could be shaping galaxies, warping space-time, and even holding secrets about the very nature of the universe itself. Think about what that means. For over a century, scientists have worked with the assumption that normal matter, protons, neutrons, and electrons, makes up everything we can see. But what if the universe has been hiding entire celestial objects made of something else, something fundamentally different? The existence of exotic stars would force us to confront one of the most troubling questions in modern physics. What exactly is dark matter? Right now, we know it's there. We can see its effects. Galaxies rotate in ways that shouldn't be possible unless some unseen mass is holding them together. Light bends around invisible structures, suggesting the presence of something enormous and undetectable. But what if some of that dark matter isn't just diffuse particles floating through space? What if some of it has collapsed into dense, star-like structures? If entire stars could be made of exotic matter, then dark matter might not be this mysterious, ghostly substance. It might be forming massive, undiscovered objects that are actively shaping the cosmos. Imagine the implications. If dark matter stars exist, then our entire understanding of galactic evolution could be wrong. Astronomers assume that galaxies form around vast halos of dark matter, but what if those halos aren't just diffuse clouds? What if they contain fully formed stars that have been hiding from us because they don't emit normal light? These stars wouldn't behave like ordinary ones. They wouldn't fuse hydrogen. They wouldn't shine in the way we expect. Instead, they might be emitting exotic forms of radiation or interacting with spacetime in ways we haven't even begun to understand. And if exotic stars exist, what about exotic planets? Could entire planetary systems be forming around these unseen objects? We assume that all planets orbit normal stars, but if exotic stars exist, then there's no reason why planets made of exotic matter couldn't exist as well. Imagine a solar system where the central star is invisible to human eyes, only detectable through gravitational distortions. Imagine planets made of strange matter, where the laws of physics don't work the way we expect. If such planets exist, then life as we know it might not be the only form of life possible. Exotic chemistry, exotic biochemistry, perhaps even forms of consciousness that we can't comprehend could arise in these bizarre environments. The consequences go even further. If exotic stars exist, then what happens when they die? Normal stars end their lives in predictable ways. Small ones become white dwarfs, larger ones become neutron stars, and the most massive ones collapse into black holes. But exotic stars? We have no idea. Some theories suggest that strange matter is stable indefinitely, meaning that an exotic star might never truly die. Instead, it could persist for billions of years, long after normal stars have burned out. Others suggest that exotic stars could collapse into even stranger objects, things that defy even our wildest predictions. Could they form microscopic black holes? Could they produce entirely new particles that haven't been observed? Could they tear holes in the fabric of reality itself? And what if we've already seen one? Some of the most mysterious objects in the universe don't fit neatly into existing categories. Fast radio bursts, intense, millisecond-long blasts of energy from deep space, have puzzled scientists for years. Could they be signals from exotic stars, releasing bursts of energy due to unknown quantum interactions? Magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's, emit strange, unpredictable bursts of radiation. Could some of them actually be exotic stars in disguise? There's even a possibility that some of the black holes we've detected aren't black holes at all. Right now, we assume that any object dense enough to warp spacetime to the point where light can't escape is a black hole. But what if some of these objects are something else? What if exotic stars can mimic the effects of black holes without actually collapsing into singularities? This would mean that some of the black holes we've identified might actually be stable exotic stars, sitting at the edge of known physics, waiting for us to realize what they are. The search for exotic stars isn't just about finding new types of celestial objects, it's about uncovering the deepest truths of the universe. If we can prove that these stars exist, then we're not just expanding our knowledge of astrophysics. We're answering some of the biggest questions in science. What is dark matter? What happens at the most extreme densities? Are there fundamental forces we don't yet understand? Could there be entire forms of matter and energy that have remained hidden from us, shaping the cosmos without our knowledge? And here's the most unsettling thought of all. If exotic stars exist, then why don't we see them? Are they simply rare? Are they hidden in plain sight? Or is there something preventing us from detecting them? What if the laws of physics themselves make it impossible for us to observe them directly? What if the very nature of these objects bends reality in ways that prevent ordinary matter from interacting with them? Could they exist in higher dimensions, slipping in and out of our universe in ways we can't comprehend? The more we think about exotic stars, the more we realize how little we actually know about the universe. Every assumption we've made about how stars work, how galaxies form, how matter behaves, if exotic stars are real, then all of it might need to be re-evaluated. And that's the most exciting part. Because science isn't about knowing everything, it's about pushing the boundaries of what's possible, asking the questions that no one else has dared to ask, and searching for answers in the deepest, darkest corners of the cosmos. And if exotic stars are out there, waiting to be found, then one day, perhaps sooner than we think, we might finally uncover the truth. The possibility of entire stars made of exotic matter forces us to reconsider not just astrophysics, but the very structure of reality itself. If these stars exist, then the universe is far stranger than we ever imagined. But the question remains, if they are out there, how do we find them? Traditional telescopes rely on detecting electromagnetic radiation, visible light, infrared, X-rays, gamma rays. But what if exotic stars don't emit any of these? What if their radiation exists in a spectrum completely beyond human detection? If so, we might need entirely new instruments to even begin to look for them. This is where gravitational wave astronomy could come into play. Unlike traditional telescopes, gravitational wave detectors don't rely on light at all. Instead, they measure ripples in space-time caused by massive objects colliding. If exotic stars exist, then their mergers could produce gravitational waves with unique signatures, signals that don't match black holes or neutron stars. And there's another clue that we might already be seeing something unusual. Some of the black hole collisions detected by LIGO and Virgo have been puzzling. Their masses don't always match what we expect from traditional black hole formation. Some are too small, others are too large. Could it be that at least some of these objects aren't black holes at all but something else, exotic stars masquerading as black holes? If so, then the evidence for their existence might already be hiding in the data, waiting for someone to recognize it. But gravitational waves aren't the only way to search for exotic stars. If they exist, then their immense gravity should bend and distort light in ways that can be observed through gravitational lensing. This happens when a massive object bends the light from a background star or galaxy, creating strange distortions or multiple images of the same object. If we can find gravitational lenses behaving in ways that don't match normal stars, black holes, or galaxies, then we might have evidence of something entirely new, perhaps an exotic star bending light in ways never seen before. There's also the possibility that exotic stars could be influencing cosmic structures on a much larger scale. Galaxies and galaxy clusters are held together by dark matter, or at least, that's the leading theory. But what if some of this dark matter isn't just a diffuse, invisible substance? What if some of it is concentrated into exotic stars scattered throughout the universe? If this is true, then the distribution of dark matter might not be as smooth as we assume. Instead of a vast, invisible halo surrounding galaxies, there could be points of extreme density, exotic stars acting as hidden anchors, influencing the rotation and shape of entire galaxies. And what about the most extreme environments in the universe, places where matter is pushed to its absolute limits? the interiors of neutron stars are already an astrophysical mystery. At the crushing densities inside these collapsed stellar remnants, normal atoms can't exist. Instead, scientists believe that neutrons are packed together so tightly that they form an exotic, superfluid state of matter. But what if some neutron stars go even further? What if, under the right conditions, they don't just contain exotic matter, but fully transform into exotic stars? If so, then some of the neutron stars we see today might not be neutron stars at all but something even stranger. This raises another possibility. Could black holes themselves be hiding exotic matter? Right now, we assume that once an object crosses the event horizon of a black hole, it's gone forever. But what if that's not entirely true? Some alternative theories of gravity suggest that instead of a singularity at the center of a black hole, there could be a stable core of exotic matter, something that defies collapse, something that remains even after a star has been crushed beyond recognition. If that's the case, then black holes might not be the ultimate endpoint of matter. Instead, they could be gateways to an entirely new state of existence, where matter transforms into something we can't even begin to understand. And if exotic matter exists, then we have to ask an even bigger question: where did it come from? Did it form in the early universe, during the first fractions of a second after the Big Bang? If so, then it might be some of the oldest material in existence, predating even normal atoms. Or could it be forming right now, in the hearts of collapsing stars or in the extreme pressures inside neutron stars? If we can answer this, we might not just discover exotic stars, we might unlock one of the deepest secrets of the cosmos. Perhaps the most mind-bending idea of all is that exotic stars could be connected to the very fabric of reality itself. Some physicists have speculated that dark matter might not be from our universe at all. Instead, it could be the remnant of another universe, a ghostly imprint left behind by a cosmic event we don't yet understand. If that's true, then exotic stars might not just be objects in space. They could be windows into another reality, composed of matter from a parallel universe that somehow bled into our own. If this is the case, then finding an exotic star wouldn't just change our understanding of astrophysics. It would change our understanding of existence itself. It would mean that our universe is not alone, that the reality we experience is just one of many, and that somewhere out there, in the vast darkness of space, are objects made of something else, something that shouldn't exist, but does. The more we think about exotic stars, the more questions arise. Could they be influencing the fundamental forces of nature? Could they be responsible for strange cosmic phenomena we don't yet understand? Could they even be the reason our universe is the way it is? These aren't just hypothetical questions, they're the frontier of modern physics, the next great mystery waiting to be solved. And if we do find them, then everything we thought we knew about the universe will have to change. If exotic stars exist, then their implications extend far beyond astrophysics. They could challenge our very perception of reality. One of the most fascinating possibilities is that exotic matter could interact with the fundamental forces of nature in ways we don't yet understand. Right now, we assume that the universe operates under four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. But what if exotic matter doesn't obey these same rules? What if it operates under an entirely different set of laws, ones that we have yet to discover? This would mean that the universe isn't governed by just four forces, but potentially 5, or even more. If that's the case, then exotic stars could be the key to unlocking new physics, revealing forces that are currently invisible to us. Could they hold the answer to dark energy, the mysterious force that is causing the universe to expand at an accelerating rate? If exotic matter interacts with gravity differently than normal matter, then it might be influencing the cosmos in ways we've never considered. And what about time itself? We think of time as a constant, an unchanging flow from past to future. But Einstein's theory of relativity tells us that time isn't fixed, it bends and stretches depending on gravity and motion. If exotic matter has a different relationship with gravity, then it could also experience time in a completely different way. This raises an incredible possibility. Could exotic stars exist outside of time as we know it? Could they be frozen in a state where time moves at an entirely different rate, or even not at all? If that's the case, then observing an exotic star might be impossible in the way we normally think of observation. Instead of seeing it evolve over time, it might appear static, never changing. Or worse, it could be so detached from our perception of time that we wouldn't even recognize it as an object. It would be something that exists in a way that our minds simply can't process. This idea connects to something even more mind-bending, the potential link between exotic matter and higher dimensions. Right now, we think of the universe as existing in 3 spatial dimensions and 1 time dimension. But many modern physics theories, including string theory, suggest that there could be more, extra dimensions curled up so small that we don't notice them. What if exotic matter is made of particles that don't exist in our 3-dimensional space but instead extend into these hidden dimensions? If so, then exotic stars might not just be objects in space, but intersections between our reality and a higher dimensional world. This would explain why they're so hard to detect. If part of their mass is leaking into another dimension, then we wouldn't see their full structure. Instead, we might only observe strange gravitational effects or unexplained distortions in space-time, without ever actually laying eyes on the star itself. Could this be the reason why dark matter remains so mysterious? Could dark matter actually be exotic stars that exist partially in another dimension, only revealing themselves through their gravitational influence? If this is true, then exotic stars aren't just a rare type of celestial object. There's something far greater. They could be the key to understanding the true nature of reality, proving once and for all that the universe is far more complex than we ever imagined. And if exotic matter can exist in multiple dimensions, then we have to ask another question. Could it be possible for life to exist in those dimensions as well? Could there be civilizations, not in our 3-dimensional space, but living in the same universe as us, just hidden in a way we can't perceive? This is where things take a truly astonishing turn. If exotic stars are connected to higher dimensions, then they might also be linked to black holes. We often think of black holes as the endpoints of matter, objects so dense that nothing, not even light, can escape. But what if black holes aren't just cosmic traps? What if they're actually doorways? Some theories suggest that black holes could be connected to white holes, objects that expel matter instead of pulling it in. If this is true, then exotic stars might be the missing link. Imagine a scenario where an exotic star forms near the event horizon of a black hole. Instead of falling in, what if it somehow maintains a stable orbit, balanced by forces we don't yet understand? In that case, the exotic matter inside the star could interact with the extreme space-time around the black hole, creating effects that seem impossible, perhaps even allowing information or energy to escape the event horizon in ways that defy our current physics. Could exotic stars be responsible for some of the strange emissions we've detected from black holes? Could they be revealing loopholes in the laws of physics, showing us that black holes aren't the absolute dead ends we think they are? And if that's true, then we have to consider an even wilder possibility. Could exotic matter be harnessed? If we ever found a way to interact with or control exotic stars, then we might gain access to technologies beyond anything we can imagine. If exotic matter has properties that allow it to manipulate gravity, then it could hold the key to faster-than-light travel. Right now, interstellar travel seems impossible because of the vast distances involved. But if exotic matter can warp space-time in new ways, then it could make shortcuts through space possible, essentially creating real, functional wormholes. This is the kind of technology that would change everything. It would mean that space travel isn't limited by light speed, it's limited only by our understanding of exotic physics. If civilizations exist that have already mastered this, then they could be traveling the universe without us even realizing it. Could exotic stars be the key to interstellar civilizations? Could they be markers of advanced alien technology, structures that were intentionally built rather than naturally formed? If this is the case, then the search for exotic stars isn't just about understanding new types of matter, it's about finding the blueprint for the future of humanity. If we can locate and study these objects, we might not just learn about physics, we might learn how to become an interstellar species. The deeper we go into the mystery of exotic stars, the more it becomes clear that they're not just another type of celestial body. There's something fundamentally different, something that exists at the very edges of our understanding. They could be relics of the early universe, hints of hidden dimensions, bridges to other realities, or even artificial constructs left behind by civilizations far more advanced than our own. And if they are out there, then finding them might be the most important discovery in the history of science. If exotic stars exist and are made of matter that interacts with spacetime in ways we can't yet comprehend, then their implications are staggering. Could they be the remnants of a universe before ours? Could they be the missing link between black holes and dark matter? Or could they be something even more profound, an entirely different state of existence that defies all known physics? To answer these questions, we need to consider the very fabric of reality itself. One of the most fascinating possibilities is that exotic stars are not just composed of a different kind of matter, but that they operate under a completely different set of physical laws. In our observable universe, matter behaves in ways dictated by the standard model of particle physics. Protons, neutrons, and electrons form atoms, which then combine to make everything we see, from planets to stars to galaxies. But what if exotic matter doesn't play by these rules? What if it exists in a framework where the forces we take for granted, gravity, electromagnetism, and even time, operate differently? Imagine a star that doesn't shine the way we expect. Normal stars generate energy through nuclear fusion, converting hydrogen into helium and releasing massive amounts of light and heat in the process. But an exotic star might not need fusion at all. If exotic matter follows a different set of rules, then it could generate energy through mechanisms we haven't even conceived of yet. Perhaps it doesn't rely on nuclear reactions, but instead taps into hidden dimensions, drawing energy from a source beyond our comprehension. This idea isn't just speculation, it aligns with some of the most cutting-edge theories in modern physics. For example, string theory suggests that there are extra dimensions beyond the three we experience. These dimensions could be tiny and curled up, or they could be vast and inaccessible to us. If exotic matter interacts with these dimensions, then exotic stars might be the first real evidence that higher dimensions exist. If this is true, then exotic stars wouldn't just be objects in space. They would be bridges, gateways between our reality and a hidden framework of the universe. Their gravitational effects might stretch beyond our own dimension, influencing space-time in ways we can't directly observe. This could explain why we haven't found them yet. If a significant portion of their mass exists outside of our three-dimensional universe, then they might not behave the way normal stars do. They might be nearly invisible to us, detectable only through strange gravitational distortions or unexplained cosmic phenomena. This leads to another stunning possibility. What if exotic stars are related to dark matter? We know that dark matter exists because we can see its effects on galaxies. It doesn't emit light, but it exerts gravity, shaping the universe on the largest scales. Could exotic stars be made of dark matter? If dark matter consists of particles that don't interact with light, then a star made of dark matter wouldn't shine like a normal star. It would be almost completely invisible, detectable only through its gravitational pull. If this is the case, then exotic stars could be hiding in plain sight. They might be lurking at the edges of galaxies, blending in with dark matter halos that surround them. If so, then studying these stars could finally give us direct insight into the nature of dark matter, solving one of the biggest mysteries in modern physics. But what if exotic stars go even further than that? What if they're not just related to dark matter, but to the very origins of the universe itself? Some physicists have proposed that exotic matter could have existed in the moments after the Big Bang, forming structures that survive to this day. If so, then exotic stars might be among the oldest objects in existence, cosmic relics from a time before normal matter even existed. This raises another question. Could exotic stars be responsible for some of the unexplained cosmic phenomena we've detected? There are mysterious sources of energy in the universe, strange bursts of radiation, unexplained gravitational waves, and objects that behave in ways we can't explain. Could some of these be the fingerprints of exotic stars? For example, consider fast radio bursts, intense flashes of radio waves that appear randomly in the sky. Some last only milliseconds, yet they release as much energy as an entire galaxy in that short time. Scientists still don't know what causes them. Could exotic stars be the source? If these objects store energy in ways we don't understand, then perhaps they occasionally release it in massive, unpredictable bursts, sending out signals across the cosmos. And what about gravitational waves? These ripples in spacetime were first detected in 2015, caused by the collision of black holes billions of light years away. But not all gravitational waves fit our current models. Some seem to come from sources that don't match what we expect from merging black holes or neutron stars. Could exotic stars be colliding in deep space, sending out gravitational waves that reveal their existence? If so, then we might already be detecting these mysterious objects without realizing it. They could be hiding in the data, waiting for us to piece together the clues. And if we do, then we won't just be discovering a new type of star, we'll be uncovering a whole new layer of reality. But there's another possibility, one that is even more profound. If exotic stars interact with dimensions beyond our own, then they might not just exist as physical objects, they could be something closer to cosmic information hubs, storing and processing data in ways we can't comprehend. In that case, they might be natural structures that encode information about the universe itself. This would mean that exotic stars aren't just made of matter. They could be made of something more fundamental, something closer to the very essence of reality itself. If this is true, then understanding them wouldn't just change our view of astrophysics. It would change our entire understanding of existence. If exotic stars hold the answers to these mysteries, then finding them becomes one of the most important scientific endeavors of our time. They could explain dark matter, reveal new dimensions, connect to black holes, and even hint at deeper layers of reality that we've never imagined. They could be the key to unlocking the most profound questions in physics, questions about space, time, and the nature of existence itself. And if they do exist, then somewhere out there, in the depths of space, these strange and powerful objects are waiting to be found. The only question is, are we ready to see them for what they truly are? If exotic stars exist, then their implications stretch beyond just being another category of celestial objects. They could fundamentally alter our understanding of the universe itself. Imagine if these stars are not just made of exotic matter, but they also influence spacetime in ways we've never observed before. If they contain unknown particles or forces, then they might be the missing link that unifies gravity with quantum mechanics, a goal that physicists have been chasing for decades. One of the greatest mysteries in modern physics is the disconnect between general relativity, which explains gravity on a cosmic scale, and quantum mechanics, which describes the bizarre behavior of particles on the smallest scales. These two frameworks have been wildly successful in their respective domains, yet they refuse to cooperate when applied together. But what if exotic stars exist in a realm where these two fundamental forces interact naturally? If exotic matter behaves differently from anything in the standard model of physics, then studying these stars could provide the missing clues to a true theory of everything. For instance, if an exotic star's gravitational influence doesn't match what we expect from its mass, it might indicate that space-time itself is behaving differently in its presence. Could these stars warp reality in ways beyond what even black holes do? Could they produce gravitational effects that extend into hidden dimensions? Some physicists speculate that certain exotic particles, like axions or strange quark matter, could interact with gravity in unusual ways. If an entire star were composed of such material, then its gravitational footprint might not conform to what we predict. It might appear lighter or heavier than it actually is, or its gravity might shift unpredictably, as if influenced by something outside our visible universe. This possibility leads us to another question. Could exotic stars be responsible for some of the unexplained anomalies in space? There are regions of the cosmos where gravity behaves in ways we can't explain. Some galaxies spin in ways that defy our understanding of mass distribution. Could exotic stars be hidden within these galaxies, subtly altering their gravitational fields? If so, then they could be the long-sought explanation for some of the mysteries attributed to dark matter. And speaking of dark matter, let's consider another radical idea. What if exotic stars are not just related to dark matter, but are actually made of it? For decades, scientists have struggled to understand the nature of dark matter. It doesn't emit light, it doesn't interact with normal matter in familiar ways, but it exerts gravitational influence on an enormous scale. Most theories assume that dark matter exists as a diffuse cloud of particles surrounding galaxies. But what if, in certain conditions, dark matter could collapse into a star-like structure? If that were true, then these dark matter stars would be unlike anything we've ever observed. They wouldn't shine like normal stars, and they might not even have a clear surface. Instead, they could be vast, swirling masses of exotic particles, held together by forces we don't yet understand. Some theorists even speculate that these objects could act as dark versions of neutron stars or black holes, with unique properties that defy conventional physics. They might be invisible in normal light but detectable through their gravitational effects or through exotic radiation emissions that don't match anything else we've seen. If dark matter stars exist, then they could help answer one of the biggest questions in physics: what is dark matter actually made of? There are many competing theories about dark matter particles. Some scientists believe they could be WIMPs, weakly interacting massive particles, while others favor axions, sterile neutrinos, or even entirely unknown particles. If we found a star made of dark matter, we could analyze its properties and finally determine which theory is correct. This discovery wouldn't just be a breakthrough, it would completely reshape our understanding of the fundamental building blocks of the universe. But what if exotic stars are even more mysterious than that? What if they don't just exist in our universe, but actually serve as connections to others? Some theories in quantum gravity suggest that certain extreme objects, such as black holes or exotic forms of matter, could act as portals between different regions of space-time. Could exotic stars be gateways to parallel universes? If these objects contain matter that interacts with hidden dimensions, then their gravitational effects might extend beyond our own reality. This isn't just wild speculation. Some physicists have proposed that certain types of black holes or compact objects might be wormholes, connecting different parts of space-time. If an exotic star has similar properties, it could act as a natural bridge between different regions of the universe, or even between entirely separate universes. If this is true, then exotic stars wouldn't just be rare cosmic anomalies. They would be the ultimate cosmic mysteries, objects that defy not just our physics, but our entire understanding of existence. And if these stars exist, then the next question is, where are they? Could they be hiding in plain sight? We might already have observed them without realizing it. Some astronomers suspect that certain unexplained cosmic signals, such as strange bursts of high-energy radiation, irregular gravitational wave patterns, or unexplained cosmic rays, could be indirect evidence of exotic matter. If we refine our observational techniques, we might soon uncover the first real evidence of these elusive objects. If exotic stars do exist, then studying them would be one of the most important scientific endeavors of all time. They could explain dark matter, reveal new dimensions, unify physics, and even hint at the existence of parallel universes. They could hold the answers to some of the deepest mysteries in science, unlocking secrets that have remained hidden since the dawn of time. And if they truly are out there, then it's only a matter of time before we find them. The universe is vast, and its secrets are waiting to be uncovered. The only question left is, are we ready to see what's really out there? This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.